This week on BSDNow, we're returning from AsiaBSDcon and giving you the reports of what's been happening there. We'll have an iSCSI tutorial for you and an interview with Philipp Bühler from the OpenBSD project. And we're going to cover a lot of things about cryptography, so you want to stick around for your weekly dose of BSD now. This is BSDNow, episode 186, The Fast and the Firewall, Tokyo Drift. Hi, my name is Benedikt Reuschling.
And I'm Alan Jude. And today is March 22nd, 2017.
Right.
Yeah.
I'm still a trip.
Our first topic this week is AsiaBSDcon. We both just got back from Tokyo a couple of days ago. We are going to talk about what we saw there. So the first day of the conference is tutorials and small meetings. And one of the first tutorials was George Neville-Neal's dtrace for developers, no more printfs. I took the for practitioners version of that last year. It was quite good. Do you know much about Warren's tutorial and how that went?
So I was busy organizing the FreeBSD Developer Summit, which was running in parallel to that one. But I was able to sneak into a couple of minutes before they started, because that one was based on the tutorial I gave last year, and Warren and Drew actually enhanced it a little bit more to reflect the current work of the documentation project and how we do things with the PO system and things like that. But I didn't actually go to his tutorial.
Yeah, so he was giving a talk about how to get started with the FreeBSD documentation and translation system, which obviously, especially in countries where English isn't a first language, that one's quite an attractive topic to a number of people. And so that one always goes over quite well, and especially with all the work Warren's put into the PO system, meaning that it extracts strings in English from our documentation, allows you to translate, sentence at a time, basically, means that we don't have the previous problem of you have to be an expert at the markup and watch out for white space changes and so on when you do translations. So hopefully this will lead to much better translations, or more current translations.
And also, people that pick up the work and know how to, work with the documentation based on what they heard in the tutorial, they might become committers at one point because they already know what to do, and they just, send patches and become, over time, a committer with the work that they're doing in their specific translation project.
Yep.
So that was good.
And then there was the FreeBSD Dev Summit. Do you remember what some of the topics we talked about were? There were quite a few.
Yeah, so it started off a little bit with introductions, who was there and what kind of topics people were interested in. We did some collecting of topics where people are interested in talking about. And that actually went a little bit faster than anticipated because I thought we had a couple more different talks. So we started with your Z-Standard compression talk a little bit earlier at like 10:30, I think. So you had enough time to present your slides. You were the only person on that day that had actually submitted a talk for the first day about your work with ZFS and including another compression algorithm, which was kind of interesting because I haven't heard about that before.
So there was quite a few different presentations. I think we spent most of the afternoon actually talking about packaging base as well.
Which is always good to do because there's still some work and coordination efforts, but we're getting there. I think
in particular, we were talking about the system allows you to have multiple versions of the kernel installed and how to deal with selecting those at boot time. And so we've kind of broke up the part where Baptiste is going to work on this part of package, and Brad's going to work on this part of the build system, and Alan's going to fix this part.
Yeah. So this needs a lot more testing, and people that are interested in that, there's enough information to get started on is all the information on the FreeBSD wiki? Should
I don't know how well notes were taken, but a lot of the topics and slides that were presented are on the FreeBSD wiki at
Yeah.
wiki.freebsd.org/dev summit.
Mm.
And then later that evening, we had BeehiveCon, which was a mini conference that we run, basically one of the nights of AsiaBSDcon. I know the very first one was actually on the Wednesday, the day before the conference, which both works and doesn't work. Not everybody could show up that early. But it gave us a little more time and put it in the afternoon instead of the evening. Although sometimes, especially for people that live in Tokyo and so on, having it in the evening meant it was easier for them to attend. So we're still trying to figure out for next year. We need more time, but we can't run it out into the middle of the night. So we either need to maybe move it back to Wednesdays and have to deal with some of the stuff more independently rather than piggybacking on AsiaBSDcon, or trying to condense it, or I don't know. I don't think we could really try to do it both nights of the.
That would be a little bit
and it would
difficult,
interfere with the Dev Summit dinner.
Yeah, but we found out that BeehiveCon is actually getting more and more interesting talks that we have time for. So we need more time for actual BeehiveCon, like a full day or even an afternoon and the night for people to present talks and also have the chance to talk about what kind of things we could do in collaboration and what kind of new virtualization avenues we could approach together, because many of those projects or presentations try to solve similar problems, and having discussions about how we approach certain problems is good to have, rather than just present and then, time is up, we have to leave.
Yep. So the list of talks and the PDFs of all the slides are up at beehivecon.org. Roger Monet gave a talk about Zen, and basically Zen as a DOM0 or DOM-U on FreeBSD. So I had to host VMs using Zen on FreeBSD and the improvements going on there. Then Mihai Karavas talked about porting Beehive to run on ARM processors like ARM64 and so on, and a bunch of other projects that his students have been working on. And then Benedict Reuschling, do you know who that is? I've never heard of him.
I don't know. I've never met him. So
he gave a talk about browser-based remote desktop VNC and SSH using Guacamole. So how to actually control your VMs from your web browser without having to have a client installed and so on. Very useful. Yep. Mike Larkin gave an update on VMM and VMD, which is the analogous system to Beehive for OpenBSD, which is coming a long way. He talked about some of the challenges they were facing, but actually since that talk, he's actually managed to get, I think, 1 or 2 different Linuxes to boot at least most of the way in it. So if you've been following that and wondering about more detail, check out the slides. It's all there. And then Michael Dexter gave an update on Beehive for AMD 64 and showed a list of all the things that have been committed. And you see actually a lot more work than I thought has been going on in Beehive lately. And also a list of things that are, started or installed or are almost finished but stalled, or things that are, being worked on now, or things that are planned to be worked on next, and trying to decide what's where and so on. And then at the end, Kristaps Dronson gave a talk about Pledge versus Capsicum and different security sandboxes, and that turned into a very lively discussion about the merits of each of those systems.
Yeah, pros and cons, and from my view, everyone was, trying to solve the same problem. It was just a matter of, what's easier to use in the code and how easy it is for people to use one of those two systems. But in general, they both provide the same security measures that people want to have, those systems.
Yeah. So that was the first day. Then
we're just getting started.
Yeah. During the second day, Kristaps actually gave a tutorial on how to build a secure web application for any of the BSDs in C. So actual practical strategies for building a web app using Capsicum or Pledge and so on. And then the NetBSD had their summit, and FreeBSD had their summit going on. And in the afternoon,
Second day.
Benedict gave a tutorial about managing BSD systems with Ansible. Could you tell us a little bit about that and how it
Yeah.
went?
Yeah, that was amazing. So usually I arrive a little bit earlier in the room to set up my machine and make the projector work. And more people kept coming into the room. And I was like, wow, there's a lot of people interested in that. And, so like 10 minutes before we started, Hiroki came in and I asked him, hey, how many people do I have in this tutorial? He said, 14. Wow, 14? That's a lot. Yeah, that's apparently the biggest tutorial that they had this year.
Mm-hmm.
So I was very happy. And so managing BSD systems with Ansible was the title, and it was based on one of my, so I give a Unix lecture at my university, and I did another section this year for the first time about Ansible. And I thought, hey, wouldn't it be nice to have the same material also available for BSD people or people who are interested in running Ansible on their BSD systems to manage their systems. And that's what I did and submitted it. And AsiaBSDcon thankfully accepted that. And based on the attendance numbers, I will also put this tutorial into other conferences like EuroBSDcon, for example, because I guess many people are interested in these topics and, IT automation and how to make sure that once you manage multiple machines and you need to make the same changes to the same number of machines, that these changes are consistent and are not overwritten the next time you run that thing. And all these things is one thing that can be done by Ansible. So the tutorial basically starts how to get Ansible set up, which is not very complicated. You basically install the software and make sure that the target systems have SSH keys that you can remotely log into them. And then I basically start with doing basic commands like a ping, or you copy a file to all these machines, or you pull a file from different machines, or some other, you install packages. So the typical system administration stuff that you would normally do on multiple machines are now being done in parallel and in a consistent way. And then I describe how you can write playbooks to manage your machines even more consistently with, like, you have a couple of commands. Like I give the example of installing a web server. So first you need to install the web server software. Then you need to make changes to the configuration file of the web server. Then you copy the files that you want to host on your website to it. And the last thing is that you need to start the actual web server service so that the pages get put onto the web. And that's what I described there as a playbook. So it's a whole complete example for people to try out. And that basically rounds up the tutorial, and people get enough information and code snippets to start from there on their own, I hope.
Yeah, I think it's very useful and important for us to have more sysadmin featured content like that at the conferences in order to get more people into the conferences. Because,
Right.
It's often easier to turn someone that already knows about a BSD into a developer than someone who knows about developing but not about the operating system to get interested in developing it. So I think getting more people into the conference, because they're going to come for this, full day Ansible tutorial thing or whatever, and then stay for the rest of the conference and get more intrigued in stuff, I think is a good approach for attracting new people. So I would like to see more of these tutorials happening. I just haven't got around to giving my own yet.
Yeah, it's difficult. I mean, giving a talk is one thing, but giving a tutorial is another. You also have to not only talk to people about a certain topic, but you also have to, help them if they get stuck somewhere or don't understand anything. So it's a little bit more effort to also prepare the materials. Not going to say that talks are easy, but it's a different kind of, presenting your material. And I guess some people are more like to give talks a little bit more, and some people do a little bit more teaching. That's what I do. So tutorials are a good way to not only get more information about a certain topic that you're interested in, but also, practice your speaking skills, and working on your feet and trying to, there's a question I haven't heard about before, interesting, and that person needs that right now.
It's a much more relaxed environment, and usually it's 15 or 20 people instead of 100.
It's not like a big lecture hall where you have to so that's fine. I will do this again. This was a fun experience. On that day we had a Dev Summit dinner at a nearby restaurant. Yes. They had dinner reservations for us. That was kind of nice. It wasn't a little bit. We should have had a little bit more food there, but in general, sitting down with a couple of people from the Dev Summit and continue talking about the things we talked about.
A last-minute organized thing for, what was it, like 20-ish people? So, yeah.
But in general, the idea was good, and I think next year we should have this a little bit more organized up front, so we can find the way to not only sit down, have enough food, but also get the talking done with each other. That's the important part.
Yep. And then the main conference actually starts the next day. So we got lots more stuff to go through. John Hickson gave his talk about how to actually understand and use NFS v4 ACLs. So you can check out the slides for that if you're interested. Jörg Sonnenberger from NetBSD gave a talk about how to bulk build packages in the many-core era. Now that their machines, even, the embedded ARM things even have multiple cores now, so it's different challenges for building packages. And then Philip Buehler actually just talked about how to use PF and R domains to create multi-tenancy firewalls. So there's that. Drew gave a talk about administering BSD systems using sysadm. So that was written by Chris and friends for TrueOS, but is available as a port on FreeBSD and works there as well. So it means you can actually use the sysadm thing to manage a FreeBSD server from your phone or your desktop or whatever makes sense for you. Then
there's a talk about ext4 extend and ext3 H3 dir read-only support in NetBSD.
Yep. So extending support for the Linux file systems on NetBSD. So that one's definitely good, and it's from a student, which is also good.
Because we want to get more students to conferences in general, to get contacts and get them involved in the project if possible. And of course, Peter Hessler gave a talk about bidirectional forwarding detection, implementation, and support in OpenBSD, which was interesting to listen to.
Yeah, so that's basically making sure that packets are going in both directions, and that more quickly detecting when there's a problem between two routers. So normally the routers only, the link between them will time out if they don't get any messages for 5 minutes. But if you're trying to do high-scale internet stuff, you want to be like, hey, are you there? Hey, are you there? Constantly. And be like, hey, I notice packets are not coming back. Send a probe to make sure that things are still working properly. And if not, be like, all right, we know that link is bad sooner. Let's flip things over and get it going the other way.
Yeah, and then was the lunch break, which is at AsiaBSDcon a bento box, which has a little drawstring on it.
And you pull this drawstring all the way out. It comes off entirely. Don't worry, you didn't break it. That's supposed to happen. And then don't touch your lunch for a minute. And then all of a sudden there's steam and then smoke. And anyway, your lunch will steam and fizz at you for a few minutes. And then once that's done, you can eat it. And hey, your lunch is warm.
Yeah, that's a very ingenious thing that only seen in Japan. So
yes, it was very interesting.
One of the treats from AsiaBSDcon.
The bento box is nice because you get quite a selection of different things to pick from for lunch, and so you get a little bit of everything. Like even the rice, they give us, I think, 3 different kinds each day,
and it's delicious. Wow!
It's like, and this is like a pre-prepared lunch in a box. Imagine what the restaurants are like. Then there was the project.
So one good reason.
There was the project update session where each of the projects came forward and talked a bit about what they've done in the last year, and a couple other announcements, but we'll talk about that later. So that was quite good to be able to briefly catch up with everybody. Then in the afternoon,
everyone else was working on.
In the afternoon, Chris Moore gave a talk about how PCBSD evolved into TrueOS. Pierre Ponchery gave a talk about hardening package source, which is the multi-OS packaging system. Then Henning Brouwer gave a talk about TCP SYN floods, an old yet current problem, and how they improved how PF deals with it. Then Mariusz Zaborski gave a talk about case studies of sandboxing-based system with Capsicum, talking about how we've, the small group of people working on Capsicum have gone through and Capsicumized a number of applications in the base system and what we learned from doing so, about, how to make it easier and how to try to design future apps to be more sandboxable and so on. So that one's very good. I wish I could have been there to see it, but I was at this next talk, which was also good. Turns out 3 of the talks I really wanted to see the most out of the whole 2 days were all 3 of them at the same time.
Yeah, always difficult. But there are recordings, and I hear that the recordings will be available end of April. Okay. So I think you should be able to access them later on at the conference website.
Cool.
But yeah, especially for those tracks that have 3 good talks in parallel and you can only be at one, it's very difficult.
Yeah. So the next one was Sam Gritter gave a talk, The History and Future of Core Dumps on FreeBSD, which actually traced all the way back to like version 6 Unix, and then forward from there, basically from core dumping on punch cards and tape, forward through full core dumps, then into mini dumps, and then into text dumps, and then talked about the future, which hopefully will have, now we have encrypted dumps, which we talked about, was it 2 or 3 weeks ago with Conrad, but also compressed dumps, network dumps, and a bunch of other features, hopefully eventually leading to dumps onto zvols, so that if you do need to do, say, a full dump or even just a large mini dump, you have that option without having to need that much dedicated swap space. You can just use a zvol, which you can then reclaim that space easily after. So that one's really good. There's a paper for that, which is quite good. But also, if you go to his GitHub, he has the organization mode thing from Emacs or something, which actually has like annotated versions of the email conversations he had and all the commits from the history repo all sorted out and logged and so on. It's
that was very well researched.
Yeah. And then the next one was from Brooks Davis, which was, I think, your last chance to see everything you ever wanted to know about Hello World, but were afraid to ask. I think somehow I've managed to miss that at every one of the conferences.
Oh, really?
BSDCon, EuroBSDcon, AsiaBSDcon, and FOSDEM. I've all had it. And I've missed it every time. Luckily, there are videos. I'm going to have to go back and go through that one because I'm very interested in that one.
Yeah, I skimmed the slides. I didn't watch the talk, but it goes very deep into what happens in even a very simple Hello World program in like string parsing and what the compiler does and all these details that you are normally just take for granted. It's like, it's an easy program that just prints Hello World, but there's a lot going on until you see that on the screen. Yeah, so that's that talk slot. And the next one was Li Wen with continuous integration of the FreeBSD project, giving an update how far we are already with our continuous integration work, with our Jenkins efforts, and basically a status update and new things that we are trying to implement in the next couple of months. And then there was the Zen talk. I went to that one, and I liked that because I always wanted to do more with Zen, and that actually sparked more interested in me to try actually getting something done in the Zen world on FreeBSD. And he said that there were a couple of changes coming that might be a little bit disruptive, but still Zen is a very interesting project, and we'll try to keep it running or stable enough on FreeBSD so that people can use it as a virtualization platform. So yeah, that was a nice talk. And 10 years with Dragonfly BSD's network stack was also in that same slot.
Yeah, Sefi ended up giving 2 different talks. Luckily, not on the same day for him. But yeah, talking about the evolution of the Dragonfly BSD network stack over the last 10 years. So it was good to actually see a Dragonfly talk at AsiaBSDcon. It's not every year do we actually get one of those, so it's nice to see Dragonfly stuff at the conferences.
Yeah. And
then we had the banquet
in the evening. Yeah, that's also nice. So big room, like a ballroom, full of people and food in the middle on tables, and all these Asian specialties and Japanese food is always great. Wow. Can't get enough of that. And usually in the evenings there were hacker lounges at hotel lobbies and small groups of people, going out for beers or having some hacking done in the hacker lounges they were organizing, or they were just tired and went straight to bed. But you and I and a couple of others tried to do a little bit of hacking in the evenings.
Yes, we got a bit done, didn't we?
Yeah, I was quite happy with the outcome, or as far as we could get without putting too much effort into it. I mean, it's the third day of the conference and you're already late and it's 1 a.m. and you try to be at the first talk the next morning, and it's tough between choosing staying up or being the first one in the morning at breakfast, or be at the very first talk without trying to fall asleep. Because the next morning, the second day of the actual conference, was a very interesting talk slot. That's what one reason was that I tried to get up to this one in the morning, because I wanted to see the SSH performance talk that you were giving.
Yeah, well, I didn't have a choice. I had to be there early because I was giving a talk.
Yeah. And you had to be awake enough to give the talk.
Yeah, I can never decide if I want the first thing in the morning slot or not. It's like, it is nice to then be done for the rest of the day and be able to just relax. But at the same time, it's like, first thing in the morning, come on. I think if it had been a little bit later in the day, there might have been a few more people at the talk, although the room wasn't empty by any means.
There were a couple of people interested in that talk, because, I mean, everyone's interested in SSH performance and, the different ways of how to approach that and tuning that you could do. Yep. But there were also other nice talks in that same slot.
Sefi also gave a talk about his day job, which is improving FreeBSD on Microsoft Hyper-V / Azure. So that was definitely interesting. And then Yuki Inomoto gave a talk about maintaining the NetBSD-based system using their packaging tools. So it looks like they're going to start looking at a packaging-based type thing as well. That's definitely interesting. And then I gave my talk about SSH performance, which is a series of different patches to try to make SSH perform better over long fat networks, so high speed but high latency links. So ZFS replication to Germany and Australia was my main use case, and fixing the sliding window stuff for that, and actually using the having SSH not try to limit the size of the TCP socket buffer if it's a non-interactive session. So yeah, a little bit of cleanup, and I hope to get that one upstreamed into OpenSSH. Then I have a number of improvements to the HPN patch set, which is a patch set that was originally designed for this purpose of improving networking. So some more specific to the use case of trying to push data over SSH patches that could go there. And then one patch that maybe isn't a good idea at all, but which is in addition to the none cipher option that the HPN patches provide optionally, where you can choose to not encrypt the data as it goes across SSH, I made a none MAC option, which allows you to skip the message authentication code, which is basically a hash on each block that makes sure that the data wasn't modified in transit, whether or not it was encrypted. The problem is that with the null cipher, the MAC is actually the slow part. So you can actually get higher transfer speeds by using one of the newer encryption algorithms like AES GCM than you can by having no encryption. and just having the MAC. Because
I remember now.
AES-GCM is an authenticated cipher, meaning in one pass you get both the encryption and the authentication. Whereas normally you encrypt, and then once you're done encrypting it, you also make a MAC of it. And part of the reason for that is it means that even if the data is encrypted, you don't want anyone to modify it, because they could modify it in such a way that you decrypting it could trigger a bug in SSH or something and crash it in code execution or something. But when you're just trying to replicate data over your LAN at ZFS at 10 or 40 gigabits, skipping a lot of that maybe is an okay option.
Yeah, especially if you have a huge number of data to transport.
So based on some feedback I got there and some future work I'm working on, the version of this for BSDCon should be even better.
Oh, okay. Exciting.
Yep. And then Zoe Lin, or Lee, sorry, gave an interesting talk about FreeBSD-powered LCD advertising displays in waiting rooms along the high-speed railway in China. So FreeBSD being used in an embedded platform, which is good to see.
You would never think about that. Yeah, it's very interesting where you sometimes find the BSDs in things you would normally don't think about. That there's an operating system in there. There's an advertising display.
Yep. Then there was another very interesting NetBSD talk, which is applying machine learning to improve the apropos command, which is basically a way for you to search when you're looking for a man page, but you don't know the name of the utility. So he's like, I need the man page that tells me how to do X. And I don't necessarily know what the command is, so I can't look up the manual page for the command. So apropos allows you to do basically a text search of the man pages. But by applying machine learning, you can improve the results you get so that you're more likely to actually find what you're looking for. That is pretty interesting. And then Emmanuel Vado gave his talk about FreeBSD ARM before the kernel and how that actually works, embedded stuff, which is quite interesting. Then the next talk I saw was challenges of doing 100 gigabits per second of TLS encrypted traffic on a FreeBSD kernel. So this
by Scott Long from Netflix. Yeah.
So this is talking about how Netflix manages to actually pump a to saturate a 100 gigabit line coming out of a FreeBSD machine with TLS encrypted traffic while still having some idle CPU left. And that's with a single socket. So they have one CPU, not two.
That's impressive.
Yes.
Yeah.
And interesting, what he also talked about was trying to generalize it a little bit so it could be upstreamed. Like right now, it's very specific to their workload and very specific to TLS. But if it could become a socket option, then you could literally just say, write this data to this socket. But first, I set an option on this socket that says, hey, kernel, please do this transformation to the data before you send it. So it's possible in the future we might actually be able to have the, say, encryption in SSH offloaded into the kernel by saying, set sock opt, do this encryption, this bulk encryption to it, and then write this data to the socket, and it just goes out the other side already encrypted by the kernel, allowing you to avoid having to copy the data back and forth as you encrypt it all the time.
Yeah, there's a lot of overhead there.
Yeah.
That would be a cool addition.
And then currently it only works in one direction, but possibly making it work in the other direction as well, so that you could decrypt data incoming. Netflix doesn't really have to worry about that because all they get back are requests and ACKs. Your TV doesn't send any data back to Netflix. It just says, I want this episode, and I got that chunk. I got that chunk. I got that chunk.
Yeah, start streaming. Yeah.
But generalizing that so that it's a more useful system will be quite nice. And Netflix's motivation is, if we get this upstreamed, then we don't have to maintain this patch anymore. It'll just always be there and working. So,
and that's a good idea if people have something that is not only specific to their use case, but can be generalized so that other people, it doesn't matter what kind of data you're transporting. It can be also used for other things, except video or whatever you want to have. If it's generalizable enough and it can be part of the kernel, then why not put it into the actual project upstream and give it to everyone if it's not a very secret part that you need to be careful not to give out, that people might not become competitors of you. But this is such a component that is very helpful to many other people as well. And yeah, what's next? The portable hot plugging, NetBSD's UVM hot plug API development. I didn't see that one, but it looks interesting.
Yeah, it was nice to see so much NetBSD stuff. I know at BSDCon last year, I think one NetBSD developer that was there apologized at the end and said, we'll try to do a better job of submitting NetBSD talks. But it was nice to see such a good showing for NetBSD at the conference.
Yeah, especially at AsiaBSDcon, where they had a booth there with a couple of interesting machines there. And that also gave probably the NetBSD people a good reason to come to the conference as well.
And then Gambold gave a talk about writing a FreeBSD IR driver for small ARM boards using EVDev interface, so that you can interface with those small boards using infrared signals and remote controls and things like that.
And there was another lunch, of course, always nice to have. And then we had a keynote about software stacks to enable software-defined networking and network function virtualization.
Yeah.
That one was kind of long. It's 1.5 hours on the schedule. But they probably left some time for discussions. I also wasn't at that one, unfortunately. But I hear good things about it.
Yeah, that was given by people from the NTT Labs, which is a major telco and global transit provider. So yeah, they know quite a bit about networking and trying to virtualize it. So that one will be very interesting to catch up on. Then quickly in the afternoon, we had Bernard Spill talking about LibreSSL on OpenSSL and FreeBSD. Ed Mass gave a talk about reproducible builds in FreeBSD, which is mostly working now, which is great. Andrew Turner gave a talk about creating a generic kernel for ARM. So we have a single kernel configuration that works for any ARM v6 platforms, which before each had to have their own specific one, which should ideally mean that more new devices as they come out will just work. And then Baptiste Toussaint and Anton Jacotot gave their comprehensive and biased comparison of OpenBSD and FreeBSD, which is kind of
nice. They did the trial run was running at the BSD Dev Room at FOSDEM, which I didn't see, but that one at the conference, that was very nice to listen to.
It's basically a scripted stand-up comedy routine between the two of them, but is actually a hard-hitting look at the pros and cons of how each one has approached different things like packaging and flavors on OpenBSD, which is simple but works today, and then how Baptiste hopes to do it on FreeBSD, which maybe will have a couple more features, but still doesn't exist at this point. And basically them going back and forth, needling each other about when one of the OSs is better at something than the other. And then when Antoine tried to skip over the storage section, Baptiste had like 6 slides of just additional exclamation marks after storage. That was quite entertaining.
Yeah, they had some sound effects in there, and that was well done. I mean, if you have two speakers going back and forth at each other, you also have to be, good at timing issues and finding the right things and you also have to leave some pauses for the audience to laugh a little bit. And that was well scripted.
And then Taylor Campbell gave a talk about holding on to things in a multi-core world. This is about trying to avoid migrating processes between cores in order to keep cache coherency, but deciding when to do it, but deciding when to not. And then lastly, Mihai Karabas gave his talk about ARM or Beehive on ARM, the current state analysis, and an overview of the porting process to hardware platforms, which might be useful to somebody if they decide to try to port Beehive to a different hardware platform.
Yep.
Yeah.
So that basically wrapped up the talks for the last day, but then we also had a work in progress session for people to,
5-minute
tell everyone what they're working on. Yeah.
Quite a few different ones, including a FreeBSD powered robot. So it was a robot based around a Raspberry Pi Zero, but it was actually a tank with treads that drove around and shot at OpenBSD people.
And tweeted its status,
yes, it also
where it was currently.
It has its own Twitter account as well. I think it's FreeBSD tank or FreeBSD demo tank or something like that on Twitter.
Yeah.
Yeah.
Yeah, that was nice. And of course, it's always difficult to end a very good conferences and saying goodbye and thanking people, and
Yeah, it
it's
was weird. It was
always
like, it's over already. I'd
yeah,
been
it's
there.
like we started yesterday and it's already over.
I got there on Saturday night, and then I did, just touristy and social stuff on Sunday, Monday, Tuesday, and Wednesday. And then we had the Dev Summit Thursday, Friday, and then the conference Saturday, Sunday. But I wasn't really ready to
over
be
like
over yet. I'm like, I still
yeah,
want to talk to these people. What are we going to do? It's like, oh, well,
yeah,
see everybody at BSDCon.
yeah, and in between, yeah, it's difficult to. But then you need to have time between conferences to work on your own things and incorporate all the
Yes,
new things that
I,
you heard
I
about.
do need to get more work done. So I suppose it's useful to have a break instead of just a conference that goes on all year long.
Yeah.
Yeah.
Yeah, so it was a very good conference, and thanks again for all the organizers who did, put it all in all the work that made the conference such a success, and Sato-san, and in
The whole
especially
organizing
his
committee.
position as an organizer and keeping all the threads in his hands, and doing
Yeah.
all the things behind the scenes that we normally don't see. It's quite impressive to run this show.
Like literally you don't see. They put up little barricades so you can't see while they're working. It's
Yeah.
very Japanese. So anyway, I guess we still have a whole other rest of the show to get going, so we should do that. So the next news story we have is TrueOS has published new community guidelines.
Oh yeah.
So the TrueOS project has existed for over 10 years now. Until now, there was no formal defined process for interested individuals in the TrueOS community to earn contributor status as an active committer to this long-standing project. So they've replaced the, malevolent dictator model with a core team. So TrueOS now has a core team that consists of Chris Moore, Ken Moore, and Joe Maloney. And they want to provide the community more opportunities to directly impact the TrueOS project. And they wish to formalize the process of interested people being able to gain full access to the repo. So it describes what's expected of community members, respecting all the members of the community, regardless of the level of contribution. And if there's a change that's disputed, it'll be backed up by the core team until the resolution, and then it'll be recommitted or not. It says, do not fight in public with other members of the community. It looks bad and it's demoralizing. I think that was an important one.
Yeah, very important.
But in particular, they spell out the exact process in order to get TrueOS write access to their GitHub repo. It says, previously, Chris directly handed out commit bits kind of whenever he felt like it. Now, the core team developers have provided a small set of requirements. They want that you've created at least 5 or more pull requests to the TrueOS repository within a 6-month period, that you've stayed active in the TrueOS community through at least one of the available channels, whether that's IRC or Gitter or Discourse or whatever chat method you like to use. You can actually request commit access from core developers by emailing them, or the core developers can contact you because you've sent so many pull requests. In particular, they say the pull request can be any contribution to the project, from minor documentation tweaks to creating a whole new utility from scratch. What's really interesting is this other policy they've come up with. At the end of every month, the core developers will review the commit logs, remove elements that have caused breakages or whatever to the project or deviates too far from the intended purpose of TrueOS. Additionally, any outstanding pull requests with no active dissension will immediately be merged if possible. For example, a user submits a pull request which adds a little-used OpenRC script. No one from the community comments on the request or otherwise argues against its inclusion, will result in it automatically being merged at the end of the month, and then at the end of the next month it'll be reviewed to make sure it didn't break anything. In this manner, solid contributions are routinely added to the project and never left in a state of limbo.
Yeah, so we don't have any, bug databases that keep growing patches and patches and patches.
Yeah, well, in
no
particular, the patch is sitting around. If no one objects to it, then we'll try it for a month and see, rather than letting it sit there until someone's motivated to actually try to push it in. We'll have to keep an eye on and see how that works for them.
Yeah, especially when the project grows with more people and there's more coordination work and all these things can... They can work in a small project, but the bigger you get, the more things you need to keep in your community and also try to coordinate between each other.
Yep. And they also go on to describe the perks of being a TrueOS committer. So it says committers to the TrueOS project enjoy a number of benefits, including a personal TrueOS email alias at trueos.org, full access to manage the TrueOS issues on GitHub, so you can actually help field PRs and so on that come in and issues on GitHub. Regular meetings with the core developers and other contributors, access to private chat channels with the core developers, recognition as part of the who's who on the TrueOS developers website, the eternal gratitude of the core developers of TrueOS, because you're doing some work they don't have to do anymore, and you get a warm, fuzzy feeling inside.
Oh, yeah. So if you're interested in that, try it out. Send a pull request or a couple of pull requests and, request access.
Yep. So next story.
The next story is one big thing that was announced during the AsiaBSDcon first day, which is the project update session. So Deb Goodkin, the director the executive director of the FreeBSD Foundation, gave an announcement about a big donation by Intel to the FreeBSD Foundation. And that was a $250,000 from Intel to the FreeBSD Foundation to fund more development work and keep Intel in the loop with what kind of product development they're doing, and that all these things should also be part of a more timely integration into the FreeBSD project. So Intel has been previously, Intel is not new to the BSD committing game. So Intel has been contributing a couple of years into the FreeBSD project with driver development on some specific...
So it was before it was individual teams at Intel had BSD connections and contributions. Like the team that makes network cards has been doing the drivers for quite a few years. And they've been doing quite well.
And they had commit bits.
Yeah. But some of the teams that work in other areas like NVMe, they made a one-time contribution but haven't kept it up and so on. And so this is a more holistic approach where the entire software division at Intel is committed to supporting FreeBSD and ensuring that things like any drivers they write for open source are always dual licensed under GPL and BSD so that they're able to be ported to FreeBSD, even, graphics drivers and so on, making sure that those don't ever ship as not being compatible with BSD and so on.
And the interesting part about that is that they understood that it's not just a matter of fixing one part of the system, like getting better network drivers or getting better storage drivers, but it's a whole systems thinking approach. If you change one thing in the system, like putting faster networking in there, there's always another bottleneck opening up. Like you need faster storage to store that, and that also leads to other things that needs to be improved. So the whole systems thinking approach is based on what this donation is going to be about. And what we're trying to do is create a long-term relationship with Intel so that we can not only integrate their products, but also that they have a way of integrating their tools, drivers, and applications into the mainline community and get the feedback from these users of their devices, what kind of requests they have and what kind of improvements they could do as a complete systems. So that's a very interesting development there, and we try to keep you updated with new developments in that area. So things that are planned for the future is a timely support for the Intel 3D X-Point products.
Yep, that's the Optane stuff that's just started shipping now.
So there will be future things that will be coming out of that collaboration. And I mean, it's not only just the money part is a big thing, of course, but it's also trying to get more people talking to each other, to developers from Intel, from developers from the project, and trying to figure out common problems that we have and find a solution that's benefiting everyone. So that's the agreement on that one. And the foundation might be the bridge between not only Intel and other companies, but also the bridge between the project itself and the Intel folks. And the more we collaborate with each other, the more we all benefit from that. That's the takeaway from that one. Not in a specific area, not just only that specific driver or that specific network card or that specific storage system, but a whole systems thinking approach as a whole.
Well, especially now that the Optane SSDs can be, with some software, can be used almost as if they were slow RAM. And then we're going to have NVDIMMs not too long from now. And then we have, Quick Assist to do hardware offload of crypto stuff, hashing and encryption and so on. So all of those things, it'll be very interesting to see that going forward, especially if we do things like offloading the math for the parity calculations for ZFS into a Quick Assist card, and what performance impact that might have and so on.
Yeah, there's a lot of cool new things coming, and all of these need support in the operating system. And the more operating system support you have and the more contacts you have within the operating system, the faster and the better the support is going to be for those devices, which also benefits the customer and in return Intel itself. So there's a whole cycle of integration and getting feedback and bringing new things to the market, but also into the operating systems to support the users and the developers to get to the latest technologies. So thank you very much, Intel, for that big donation, and we will keep you updated on any new developments coming out of that area. If you want to support that effort, thank Intel publicly on your blogs or whatever you might have on social media. That will be a lot of help for them, seeing that there's actually a community behind the BSDs that want to see this collaboration flourish.
Yeah. In the show notes, we also have a link to their blog post over at 01.org, which is their open source hub for Intel. And you can also find a lot of their stuff on their GitHub page as well. So our last story for the first section of the show, which has been going on for a while now.
We're running on.
Yes. Is Applied FreeBSD Basic iSCSI, which is a great blog post showing how to get started doing iSCSI on FreeBSD. And it turns out it's super easy. So it says iSCSI is often touted as a low-cost replacement for fiber channel or storage area networks, which is basically having a dedicated network running a different protocol for your storage. The nice thing about iSCSI is it can run over your regular LAN, or it can have a separate VLAN, which is better, but it means it uses standard switches and routers and so on. You don't need special networking gear.
Yeah, I remember last year, or not last year, a couple of years ago when I was still a student, we had a storage networking architecture lecture, and one of the professors there was telling us about iSCSI and that you don't get a network device, but you get a local device that appears to be a local device, but it's coming over iSCSI, and that was interesting to see. And that's what this article is all about, and what FreeBSD can do in a very simple setup if you follow along.
Yeah, so iSCSI runs on top of your standard TCP/IP. It means that the same network equipment used to route user data on the network can be utilized for storage. So this article will cover a very basic setup where a FreeBSD server is configured as an iSCSI target, meaning it's the server, and another FreeBSD server is configured as an iSCSI initiator, meaning it's the client. The iSCSI target will export a single disk, so they actually have a whole physical disk dedicated in this case, and the initiator will create a file system on top of that disk, mount it, and build stuff on top of it.
Like a local drive.
Yep. And then advanced topics later, they'll talk about, or they don't talk about things like doing multipath, so you can actually use multiple network cards and different network paths to do your iSCSI. So if a switch fails or something, you don't lose your disk temporarily. Doing ZFS or doing failover controllers or anything like that, that's more advanced in this basic tutorial, but maybe that will come later. So they say the real magic is in this ctl.conf file, which contains all the information necessary for the CTL daemon, which stands for CAM Transport Layer.
CAM Target Layer?
CAM Target Layer, yes.
Probably.
Which is what makes iSCSI targets out of CAM devices. So he says, check out the man page for ctl.conf for more details, but they have a small example one here where they expose two different LUNs. The first one they expose is dev ADA0, and they expose that, and we'll do that with FreeBSD. And then they create a second LUN ADA1, which will actually show how to connect to it from a Windows client. So once you've copy and pasted or modified or written your own version of this ctld.conf, you just need to run sysctl to enable ctld, and then service ctld start, and it'll be running, and your targets will be exposed. You can use the ctl-adm command and do lunlist and see a list of the devices that are exposed, or devlist and see a list of the devices that are actually going on there. And so you're now done on the server side, right? You said, hey, ctld, here's a disk and a LUN number, here's another disk and a LUN number, expose those with this username and password or whatever, and it's good to go. You can do more advanced configuration, but that's all you need to do in order to get this working. So then over on the client side, you need to create either an iscsi.conf or use the iscsi-ctl command line to specify the IP address and name of the device. And then you can just enable iscsi with sysrc and start the service. And now it will connect. And when it does, you'll see a new device show up on your system. In this case, DA1, because DA0 was the disk in the server, or the client. So now you have this new disk, which you can see a model number is FreeBSD CTL disk 0001. And it basically, you do operations on that virtual device. iSCSI translates copies those SCSI commands that you're performing to it over the network back to the CTLD, and it actually performs them on the real hard drive.
Yeah.
And that real hard drive doesn't have to be SCSI. It can be AHCI, it can be whatever. Actually, with iSCSI, it can even just be a file on your regular file system. And so then you can use iSCSI CTL minus capital L to list the connections that are going. You can see what happens, when you disconnect it and so on. But then they go through and they partition the disk, add a FreeBSD UFS partition, format the partition with UFS, make a mount directory, and then mount it. And now you have a /iscsi shared directory that's a UFS file system on the hard drive on a different machine. And you just use it, and it works. And it's great. And it also shows you how to unmount it and disconnect it for when you're finished. But, if that looked easy, that's because it is.
Yeah.
It's a little bit more work to do it on Windows, but you can do that. So in this case, they've set up a brand new Windows server, and they're going to use the iSCSI initiator in Windows to connect. And so they start the iSCSI service.
Yeah, they have a built-in one, right?
Yep. So you start the iSCSI service, you enter the IP address of your FreeBSD server, and then you'll see it has a list of your different targets, and you've connected to it. So we now have that device, and we point it at the LUN we want, and now this new disk shows up in your Windows panel, and you can partition it and format it and run NTFS on it. And it's actually the hard drive in a FreeBSD server on the other side of the network.
Probably running ZFS.
Well, in this case, they exposed the entire raw hard drive via iSCSI, but you can do it with ZFS using a ZVol or as just a file on UFS or ZFS. File adds some overhead, so I recommend the ZVol. And that means that your ZVol now can be snapshotted, replicated, and it also means that it's got all the protections of ZFS and the checksums and so on. But you can format it NTFS and connect it on Windows and use it like that. If you're really adventurous, you can actually have Windows boot from the iSCSI disk. That usually requires a network card that supports iSCSI in the network card. But it means you could have a Windows machine with no disks in it at all.
Use that to get your stuff, or
and connect
put
to the
your swap
iSCSI
device on that one.
Yeah, or whatever that type of thing you might want. But meaning that you can have a Windows machine where all the storage is actually backed by FreeBSD and ZFS and isn't going to cause you headaches in the future.
Or you export that to a virtual machine. Could also be a thing.
Yes, VMware and so on loves to use iSCSI for the virtual machines because it's lower latency than virtualizing files and so on.
Yeah, so check that out.
Yeah.
It's a nice tutorial, and make good use of that.
And finally, our this week's episode of BSDNow is brought to you by IX Systems. Go to ixsystems.com/BSDNow to get the ultimate guide to buying a new server for open source. Basically, it's a short little PDF that kind of walks you through some of the advantages to considering using IX over a regular hardware provider in order to have servers that has been tested to actually run the workloads that you're going to try to run and have been optimized for it. And talking to sales engineers that actually know what FreeBSD is or what OpenBSD is and know which hardware actually has the best drivers on BSD and, which type of SSD you want if you're trying to do a read cache in ZFS versus the other type of SSD you might want if you're trying to do a slog, a write cache. And, which type of hard drives you're going to want. Or, hey, I've got all these drives, or I need at least this much space and this many IOPS. What kind of drive should I buy and what ZFS layout should I put them in? Or, I built this server and I want to be able to add more storage to it in the future. So so what you want to do is make sure that you have, some empty PCIe slots so that you can add external storage controllers and hook up some sleds that are just full of disks to your server later on and just add more storage.
Yeah. And they have a lot of experience, running ZFS servers and what kind of, future needs you might have in your storage and what kind of different server configurations you never thought about running, but they can configure you the servers any way you want for your specific use case. So you don't get a standard server off the shelf, but something that's been built to your specific use case for your business, for your company, for your specific needs that you have for this server or where this server is going to be used in the future. Whether it's big data or a cloud server or something for finance, everything is there that you can ask them for. And just tell the people at IX what kind of system you're going to run and what kind of needs you have from your customers or from your environment, and they will tailor you a very specific solution that is tailored to your specific environment.
Yeah. Tell them what problem you're trying to solve, and they'll be able to build you a better machine than if you just tell them I need a machine with this much RAM. I've seen them build water-cooled systems for people. It's like, we're doing science, and we need really high clock speed on a low number of cores. Okay, we'll build one based on an i7 and water cool it and then just crank it up. Or somebody was like, I need a lot of network capacity. Like, with some custom metalwork, we can fit 24 10 gig ports in this machine. Yeah.
That's something you don't usually get.
Yeah. So they can go to all kinds of extremes to get you what you want. So you definitely should check them out. That's ixsystems.com/BSDNow.
Yep. Check out their server buying guide and all the other things they're offering, like the TrueOS all-flash and hybrid storage arrays, and all the other things they offer on their website. So we're live now on our interview section today with Philipp Bühler. First, welcome aboard and our little show here. Philipp is the technical lead at Sys5 company and a former OpenBSD committer. And the first question we always ask our first interview guests is, how did you get introduced to BSD and Unix?
Oh, well, I started my computer journey when 8-bit was all of the show, so it took quite a while to get into Unix. But eventually, after 10 years or so, we had Skype would call it nowadays like experience enhancement, from going from VEX VMS to alpha machines with OSF1. And also the CAD machines have been on a 32-bit Unix derivate from the city of Munich. Was called Munix, not Mini, but Unix.
How fitting.
Yeah. And while trying that, I was also seeing in a record label shop that they offered a SUSE Linux distribution. That was end of '94. And since that was based on CD-ROM, that was quite nice to install because our Polytechnic had only 9,600 baud to download, and like 80 disks to download over that. No, not really.
Yeah.
And BSD was a bit later. My older brother had a FreeBSD 2.x, I don't know, 2.1 or something, as his home router at the campus. And then my first job at an ISP had several Unisys and also an OpenBSD firewall back then. That would have been like 2.1 or something.
Cool.
So it's quite a while ago.
Mm-hmm.
Yeah, it's been some time. Yeah.
It's been interesting to see how many different BSD committers we've talked to were introduced to it because, an older brother or friend of theirs had been using some variant of BSD and got them into it. And it's like, so how does it turn out that the second generation of people that get into it are the ones that end up becoming committers, not the first set of people that use it?
Yeah, really.
So how did you eventually get involved with the OpenBSD project, and how did you get your account?
We have been using as I already said, OpenBSD with IPF or IP filter back then. And then 3.0 happened, and the whole IP filter license story and all about that. And I've been trying to migrate from IP filter to PF from Daniel. And officially it was more or less like a drop-in replacement for syntax and functionality. But of course, the first release with 3.0 wasn't quite there yet. And so I was talking to him quite a bit, like testing cornering cases I needed for us. And saying, the documentation is not quite correct and all that, and that's the problem with OpenBSD. If you criticize it, you will be invited to fix it. Mm-hmm. And that actually happened then back in 2002 in Calgary, where I also met Henning, who started his journey with OpenBSD committer at the same time. And I was there for doing especially that what I was criticizing, like documentation, testing the stuff, reviewing, and eventually get fixing some bugs there.
But you were also helping him with the PF initially, or was that the side project thing?
That was actually all in the arena of PF. I tried something with SCSI drivers. Since I had a controller in a machine which wasn't fully supported, but going into SCSI subsystem, I was sticking with networks because all this storage buses, and that's really a complicated area. Networking is pretty easy peasy compared to that. So it was all about PF.
Yeah, there might be people who disagree with you on that, but that's okay. So what are some things that we can blame you for in this or other areas in OpenBSD?
I dropped out of the project as an active committer in 2005 to 2006, since I changed job back then and didn't have just the time to test all the corner cases like I did before. Like my testing quality really dropped out, and time permitting wasn't there, since the new job didn't involve any BSD at all. So that was a poor thing. And that's over 10 years now. And so most of the stuff that has been in the tree from me is already gone again. But
overwritten.
Yeah. I mean, that Henning did a quite large rewrite of all the stuff to streamline the kernel internals to integrate PF instead of having PF at a single citizen somewhere sitting in the kernel. But what I did back then as an idea from Henning, but I did the initial implementation was interface grouping. So you can say you have an interface group of all my clients, and then add the interfaces to it, and then use it in pf.conf, just like You only need to specify the interface group instead of all the interfaces by themselves. And a lot of documentation, of course, that's probably still there, like BNF in the pf.conf man page, if anyone is ever reading that, because it's not a format that a lot of people dig. And that's probably still there. And I did the initial stripping of all the IOCTLs out of pf.c into its own file. So it's not pestering like, I don't know, 3,000 lines or so, only of boring IOCTL code sitting in all there. But yeah, that was about it. But testing the things in the PF hackathon in 2004, I was sitting at my laptop for like 40 hours to find a really, really well-hidden bug, which involved exactly that, an IOCTL between userland and kernel, which triggered a rule numbering overflow because the userland was using 32-bit in a counter and the kernel was still at 8-bit. And finding that was quite difficult because obviously it only appeared after something around 256 rules.
Until you reach that, yeah.
Yeah, and then it suddenly flips over in a quite funky way as well. So it didn't crash or something. Just you had some silly reordering of rules, and that wasn't quite fun. But it was found, it was fixed, and there it is.
Yeah. So can you tell us a little bit about how you use OpenBSD at your day job?
Yeah, not as a desktop, but we have several locations, like 10 or 11 locations across Europe, and at all the locations we use it, of course, as a perimeter firewall, and also doing a VPN of meshish. Between all the locations, and of course of our centralized monitoring, we might use IDS functionality on it with Suricata, and of course a lot of testing of new architecture and concept like routing domains, which I test locally first on a Vagrant-based system I was talking about in Tokyo.
Oh, that's quite some. I mean, we don't have, well, at least I don't know many companies that are using OpenBSD internally. So that's a good, interesting thing to hear, that people have a use for it and also use it internally.
Yeah, and it's not only a home-based firewall, but for example, at one location we have a cluster of 4 OpenBSD machines that are doing like 2-stage filtering. And it's all 10 gigabit Ethernet in between as a mesh between. So you can have pretty good advanced use of it.
Yeah. So we keep hearing a lot about this R domains thing. Can you describe what they are and what they are going to be used for?
Well, in layman terms, it would be easy to say it's just virtualized routers within one physical router or firewall, if you want to. A bit more technically, it's having one or more actual interfaces, if virtual or physical, doesn't matter. And those have their own complete distinct routing table. So all network traffic within one routing domain is completely isolated from the next.
Ah, okay.
And the use case is to have a really full separation of your network traffic between those distinct routing domains. So by no means, unless you really make some exceptions, the network traffic from one routing domain will never see the other traffic.
Mm-hmm.
So all the interfaces within routing domain 1 are completely separated from routing domain 2. And yeah, that's nice to, besides separating maybe one customer from the next or so, you can also easily test your maybe your new ideas, even in a live environment. Like you have a routing domain number 23, and you're testing there with virtual machines behind it, which have the complete same IP addresses and all that. And you're testing through that. Given is there enough speed? Are your queue settings all correct and all that? And if that is working, you can just put the same configuration into your actual live routing domain, and it will just keep working. So it's also nice to test new settings beforehand.
Yeah. Oh, that's nice. I can also imagine. So I'm working in a university, and I can think about that our networking labs or the networking classes. They have labs where they teach students how this whole internet working works or how routing works, and that could also be an application for that.
Yeah, but they could do that based on VirtualBox and Vagrant as well.
They do that locally, but once you get more sophisticated or want to do more advanced setups, then it's probably
it's difficult to test 10 gigabit Ethernet on Vagrant. I give that.
So that's good to know that these are available and can be used for that.
I mean, it's as long if you have a remote access to your firewall, as long as you are not fiddling with the interface you are logged in a wire, it's next to zero risk to fiddle around with these. If you create some vEther interfaces and put them in their own routing domain, it's perfectly fine. Nothing can happen. Mm-hmm. You can do silly stuff in there, and it's isolated. So don't be afraid.
It's always good to have students or users, run wild and do some things without you worrying as a sysadmin that they will break everything.
Yeah.
So part of what you described was doing multi-tenant firewalls. Can you describe a little bit more what that is and when you might actually need to have multiple tenants on a firewall?
I was using that term for my talk in Tokyo and Belgrade. And first I was using the term multi-customer. And then people said, well, it's all interesting, but I don't have any customer, let alone multiple of them. Mm-hmm. So I don't have any use for that, so go away. And then I was looking for a different word to have a use case for it. And tenant could be anything besides customers. It could be also different projects or different buildings on your campus or divisions of your company. Even if you have only one website or an application per se, and the application has a life cycle like development, stage, and live environments. And usually that's done that the development, the stage, and the live environment has a slightly different network setting. Like the one is on VLAN 1, the next is on VLAN 10, and then the live environment is on VLAN 100 or something. Mm-hmm. And with our domains being used as in a kind of multi-tenancy, you can use the same IP addresses in all three in all three environments, and you can just interchange it. So if you see that configuration in development is working, you can just copy paste it over, and you don't have to make those only little changes to your IP address or something, which will usually have typos or copy paste mishaps and all that, and that's just going away. Because you can just use something like 10.60.10.1 for all the three environments, because since the routing tables are completely isolated, you can have the same IP addresses up to 250 times on the same machine.
Cool.
And that's giving you a full separation of these things without reconfiguring. And if you take it a bit further, you have the students doing silly things.
Mm-hmm. Yeah.
And I have an example in my talk, so that might be looked up afterwards. You can say you have an anchor, student 1 on our domain 1, and then include etc/pf.student1.conf. and give write permissions to the student one on only that file. And then he can mess within that configuration file, whatever he decides to do, and it will only affect our domain one.
Yeah, that's exactly the use case.
And the other files he cannot write, so he cannot mess with it.
Cool.
Yeah, so tenants are have multiple meanings. Yeah, that's the important thing to know. So, speaking more about OpenBSD, what do you think are the two most overlooked features of OpenBSD that people don't usually get from their first experiences?
Yeah, obviously, our domains.
Yeah, that's an easy one.
Yeah, but I was thinking about this, and then I came across what we are using too, and I haven't seen it often. But OutPF is something that not many people are using, where you can have a login shell of OutPF, and when you log into the OpenBSD machine or SSH, you are getting a loaded on a per user basis rule set, where you can have specialized forwardings or something like that.
So it's
I think that's not
like port knocking, but actually secure.
No, it's the other way around. You log in and then you're getting 3 ports, like a port forwarding into a database connection or whatever.
Well,
but the user who is logging in cannot manipulate the actual rule set. So I can, as an administrator, write the configuration, and if he logs in, he can use it, and if he logs out, the configuration is gone again. And only his session will be able to use that rule set. So that's pretty nice. And of course, the elephant in the room for OpenBSD is documentation and man pages.
Yeah,
that's overlooked a lot. There are so many people writing complaints or asking for help, and so just look at the man page. It's down there, even with an example on exactly your situation.
Yeah, I always wonder how many people wouldn't ask questions without reading the man pages. It's like, it's all there.
Well, there are certain other systems out there, and when people get trained that, the man pages aren't any good, it's like, well,
yeah, you have to search for how-tos on the interwebs, and I say OpenBSD tries to have a documentation that works offline. That's just like back in the day. For example, the first RFCs I have been reading that have been printed out on a 9-needle printer and back home on the bus to read it. It wasn't like browsing the web. There was no web back then, and it's still trying that documentation is a very key thing, and it cannot be that use Google for having something, because then you end up on pages that are completely outdated. If we change something, pretty drastically, and then you're searching for it, maybe not yet existing feature or a changed feature, and you come over a 2-year-old page, and then you are trying that, and it doesn't work, and then who's getting the blame? OpenBSD side, and not the old age website out there. So it's better to have the documentation along with the code.
Yeah, and you can also get documentation that's wrong or dangerous. Bad recommendations.
Exactly. Yep. Like I did a talk for EuroBSDcon in 2002. Please don't look it up. It's all wrong now. Don't use it any longer.
Yeah, and it's difficult to get wrong documentation out of the web because they remember everything, and even the bad stuff keeps coming up again.
Yep.
So with that in mind, how do you convince people to try OpenBSD or other BSDs in general?
I don't. I'm not really into advocacy also. If you convince people into something, there's always the backlash of liability. Like you said, it's OpenBSD, that's cool. It doesn't work. I was hacked into, and then it's your fault. So
yeah, of course, yeah.
I'm not really into that. People have to take their own pain. They can listen to me or read my stuff, or of course all the other BSD guys. if I would argue along it, of course, it's PF and nowadays deep integration into the networking stack and the other tools that run on OpenBSD, like using OpenBGP to inject PF tables or something like that. You won't get that in Linux land or somewhere else.
Mm-hmm. So then we were going to ask, do you know of any non-BSD conferences that could use more BSD content?
I haven't been on a lot of that lately in the last years even, and it's difficult. Usually the conferences are pretty specific on a certain topic. Like maybe we do a lot of provisioning, so chef conference, but that wouldn't be quite along BSD or so. Maybe the open source data center conference could maybe have used more of BSD content. I will be there as a visitor in middle of May, and we'll look at it and maybe, I could add some content then.
Yes, actually, Benedict and I went to that one last year and added a FreeBSD talk.
Great.
So excellent. They need an OpenBSD one now.
Yeah, right. I will tell them.
Mm-hmm.
I mean, I was just coming along that the very large providers are using, for example, BGP within a data center. And, maybe Peter should give that talk, but, that's why I'm talking about that conference. And with the well-known FOSDEM has probably way enough of that, but maybe we could add more there as well.
Yeah, at FOSDEM, the BSD dev room was only half a day because we didn't have enough talks.
Okay. Yeah, let's look into that for next year.
Mm-hmm. Yeah, because then we not only have, let's say, FreeBSD talks, but we also want to get more BSD talks in general from OpenBSD, NetBSD, Dragonfly BSD. That's what this dev room is all about, not just one single project.
Yeah. And I think, like you were saying, though, even some of the provisioning and config management type conferences, that's a lot of the topic. A lot of times at those conferences, it'd be good to be like, hey, when you're writing Chef and Puppet and so on, don't forget that OpenBSD is a thing, and it'd be good if it could manage some of the more OpenBSD specific things, or use teaching Puppet and Chef and so on to use RCCTL that controls the rc.conf.
Yeah, I've been writing some cookbooks that now use RCCTL, of course, and people are always surprised that Chef runs on OpenBSD, but it's just Ruby, so.
So a lot of it runs, but sometimes it's like the built-in way of just saying create this config variable. It doesn't know about OpenBSD, and so you have to teach it about RCCTL yourself. Where it's like, if upstream paid attention.
Yeah, bug reports.
Yeah,
always the same thing.
But sometimes you just
if stuff doesn't get fixed, get your own behind up and do it.
Mm-hmm. Yes, but sometimes just reminding people at these conferences in person that other operating systems exist that aren't Linux.
Yeah. Right.
And they don't store every config file in /etc. We have user local for that.
Mm-hmm.
So
that's not a good concern for OpenBSD for me.
Yeah.
Right.
No, these small things like that, if they don't get hurt, then they assume everyone's using that path for config files or similar things.
Yeah.
So yeah.
But so what keeps you? I guess you don't work on open source that much, but what keeps you motivated to participate in open source in the community?
I've been thinking about that, and it's the answer is quite easy. I just have to look back 20 years. If you have been telling people that you work with open source projects, first, what's open source? Or if they did know a little bit about it, they have been laughing at you. And then just look what's happening now. If a company isn't at least a little bit of open source, they won't do much.
Mm-hmm.
So I can just look back, and I have maybe not any longer or whatever, but there's OpenBSD in this Mac laptop. There's running PF. And 20 years back, it would have been impossible to think that. If you look on all the commercial vendors that are using parts of BSD and OpenBSD and OpenSSH, if you want to be involved with all these commercial vendors, there won't be enough lifetime to accomplish that. And being with a BSD project, you can always say, I'm in an HP switch, I'm in Apple, I'm in there, I'm wherever else, and so that's pretty nice. And
yeah, that's true.
I don't think it will turn back into closed source.
I don't.
If you have a company telling you we are doing only closed source, that's more secure, they will all laugh at you today.
Yeah, there's another world out there that's showing that there's a difference, and then you can also make a difference as a company using open source.
Yeah, really. And the nice thing is with open source, it's obvious, but if you come into a corner situation, edges, and then if you are able to, you can check the code and maybe you can even fix it. Or you can point some other nodes into here, that's not working on a real-life scenario, and then it might get fixed.
Or at least you can reach the person who wrote that specific line of code. And
not always.
Not always, but sometimes.
Better than in closed source.
You at least have options.
It doesn't matter. Yeah, you have options, and especially what I like, even especially back then, in closed source, you get a stupid error message, and maybe it just say, "Oops, something went wrong in 0x000." And in open source, you might be able to run down that error message and then read back the code, and maybe you get more of an idea what actually went wrong. Because the developer was just lazy to have a descriptive error message. That's always a nice thing.
Indeed, yeah. So, do you also have any hobbies outside of open source?
I'm. What's free time?
I don't know.
No, I'm into speed. I'm a speed jerk, and back in my younger years, I did some car racing, like with real cars. But with degrading eyesight, I'm not longer fit to pass the medicals to get a license in that. And now I'm mostly a traveling nerd. I like to go to very remote places without any smartphone, without any laptop, just 2 weeks offline.
And see where you end up.
to really have something like a vacational effect. And if all that isn't happening, it's usually like reading older science fictions from the 50s or 70s, which usually try to describe the world in a year that's something like the 2010s. So it's interesting to see what the vision was 50 years back. Modern science fiction, not so much. Yeah, the direct comparison. Like 2 years ago, where are our Back to the Future flying cars?
Yeah.
Well, was there anything else you want to talk about?
Yeah, like I said, report box, get involved. It's not that hard. It's not rocket science, even if some BSD code made it to rockets already. But on another occasion,
we have a visitor.
Meet him.
Oh, hey.
Yeah. He's coming to Ottawa. Yeah. You all know them.
Yeah, of course. We're tracking him with our Twitter accounts.
Yeah. Yeah, he had a big party, so already falling asleep.
Yeah, he's a busy goat. Yeah.
Yeah, with Puffy and Beastie and messing all the time. Otherwise, thanks for having me doing this podcast all over the years. see you in Ottawa, and maybe I might, it's always a problem with announcing early, but I will submit a paper for EuroBSDcon about scooping the install features of OpenBSD for mass rollouts and all that. So if you want to come to Paris, I hope the talk will get accepted, and maybe that will be interesting too for all of you.
Mm-hmm.
Yeah, sounds like it. Yeah. Okay, so thank you very much for this interview, and hope to see you in Ottawa or EuroBSDcon, whichever comes first.
Ottawa, I think.
Yeah.
My flight schedule says so.
Okay, then we'll all see you there. And thank you again. And have a good time with the goat or on your travels.
Thank you to Philip for talking with us. This rest of the show is brought to you by DigitalOcean. If you go to digitalocean.com and sign up for your droplets that get created in less than a minute, you can also log into your account and enter the coupon code FreeBSDNow, and it'll add a $10 credit to your account, which will allow you to run something like their $5 or $10 per month VMs without having to spend any extra money. You know, I know Benedict apparently needs to get one of these for his Quasal core. He's having some.
Yeah, now that you mention it, I have to get one.
Yeah.
Because that's easy, because you have a specific use case. You use a certain, server product or a client, and you want to run that on the internet, and that's the right solution or use case for your DigitalOcean droplet. A specific thing that you want to run on the internet without much hassle of setting it up, and you just want to use their infrastructure for your hosting needs. And they also have a nice community page. So if you go to digitalocean.com and click on community, they have all kinds of tutorials written by users and server systems you might want to run on your DigitalOcean droplet. So there's a couple of good information there to check out. And check out their hostings and what kind of things they offer for you as a cloud computing user.
Yeah. You can choose your location and you get all the features and, immense amounts of bandwidth. Getting a terabyte of transfer included on the $5 one means you never have to worry about running out of bandwidth. And with FreeBSD, it's not wasting a lot of memory. So 512 megs of memory is enough to run your Quasal core and your website and your mail server and all those things that you might need to do. And with a price of $5 a month, and you're getting 2 of those months for free with a coupon code, it's hard to argue against setting it up that way.
Yeah, and you can also pick an hourly or monthly pricing. So on their website, you can check your monthly needs what kind of hourly needs
actually,
you have.
The pricing is always hourly. It's just capped at the monthly rate. So if you leave it on all the time. So what it means is if you started one today, which is the 22nd or 23rd of March, depending when you're watching this, you would only pay the partial rate for the rest of this month, because it would just be the number of hours from when you turned it on sometime this month to the end of the month. And then next month, you'd pay the hourly price, but eventually it'll be slightly cheaper to pay the monthly price, so they'll actually only charge you the monthly price. So it's great. So if you turn it off early in the month, it means you didn't pay for the whole month. You only pay for the hours you actually used it.
Yeah, that's really great. And again, you can check out your location where you want to have your droplets going to be running.
Yep.
London, Amsterdam, Frankfurt, Bangalore, Singapore, Toronto, San Francisco, and New York City.
It's interesting that you start in a different place than I do. Makes sense.
Yeah, I go from the other side of the world.
You start in Europe, which makes sense. But
yeah, that's my center of the world, at least, this part of town.
Right, so let's get into the news, or the rest of the roundup. So we have first half a dozen new features in Mandoc. Can you tell us a little bit about this?
Yeah, so Mandoc is already a nice man page renderer, but it also has an HTML mode. So if you do mandoc-t HTML, capital T that is, and that will switch into HTML output mode. You can see that in the additions that they made, a new feature, you can see that the semantic function of the marked up words by hovering your mouse over them, which is kind of nice. And In the terminal output modes, they now have CTAX-like internal search facility built around the less tag jump. And the feature for that is that has been in there for quite a while now. But the new addition in there is that they now have a similar feature in the HTML output mode. And if you want to jump from the same place in the text to go to the you go basically to the address bar in your browser, type a hash mark after that URL, and then the name of the option, command, variable, error code, whatever you're looking for in the man page you want to jump to, and hit enter, and it will automatically put you into that position. And there's a full report about all the changes. There's many more that we couldn't list here in its complete entirety. But Ingo Schwarze put out a full report, of course, rendered in ManDoc itself, that describes all these new features. And that is something you should check out because it has a lot of new features which you might find interesting. And since ManDoc has also been ported to FreeBSD and other systems, these systems will benefit from those additions as well. And so it's
relatively soon,
something you should definitely, I guess people are eager to get those features. And try them out. It's a nice thing. And if you want to do more work in HTML mode of ManDoc, check out these new features.
So the next one I have here is actually from 2014, but I was talking to the author of it recently and started working on a FreeBSD version of it, and so I thought I'd cover it since we never have. Mm-hmm. So this is from Sasha Kiselkov, who's a ZFS developer, works at Nexenta, and he's responsible for a number of the features in OpenZFS, including upcoming stuff. He's doing the persistent L2 arc, where it'll reload the content of your L2 arc at reboot instead of it just going away every time you reboot. He's also working on a faster version of Resilver that can be up to 16 times faster resilvering your disks, which could make a big difference for people. But he worked on things like LZ4 and a bunch of other interesting bits in ZFS. And the trim. He's working on trim support. Now, FreeBSD has had trim support, but this will be even better, and it'll be universal across all the different types of ZFS, or different OSs of ZFS, so it'll be really nice to have. So anyway, he says, recently I've been motivated to look at the kernel crypto framework in IllumOS and discovered that, unbeknownst to me, we already had an AES-NI implementation, and it was automatically enabled if you were running on an Intel or AMD CPU that had the feature flag. This work was done back in 2010 by Dan Anderson. He says, this was great news. So I set out to test the performance in IllumOS in a VM on my Mac, which is a Core i5 3210M, which is 2.5 gigahertz with turbo boost to 3.1 gigahertz. The initial tests of what the hardware can do were done with OpenSSL as kind of a control experiment, right? So we found with AES CTR, it could do about, almost 3,200 megabytes a second. AES CBC was under 600 megabytes, and AES GCM was about 1,000 megabytes per second. So that's what he got for his control test. And he thought, okay, that seems pretty good. Now, it actually goes in here and talks about the different modes for a little bit. He also mentions the electric codebook mode, and then explains, uses one of the canonical examples to show why it's bad. In this case, encrypting the picture of the Linux penguin with electronic codebook mode. And you can, while the image is obscured, you can actually see in the pattern that it is still a penguin. And this is why that's not a good mode to use for encryption. But then he talks about counter mode and how that takes a little bit more, but is about the same performance, and so it's definitely better to use. Or cipher block chaining, and how that's basically using some data from the previous block as the key for the next block, so that each block is, so that if the same word appeared in multiple blocks, it would be encrypted differently each time, and so on.
Okay, so
and it goes along.
That's
so there's lots of background on that. But then he says he tested it using the kernel crypto framework, and he found performance was terrible. Even using 128K operations versus the 8K operations, which OpenSSL is testing. So you would expect this to be faster than OpenSSL, or at least the same. Found that
but it wasn't.
All of AES CTR and AES CBC were both only doing about 110 megabytes a second. Versus CTR was doing over 3 gigs a second in OpenSSL. And CBC was doing 500 So
That's quite a
between
difference,
5
yeah.
times and 30 times slower. And AES GCM was only doing 56 megabytes per second, and it should have been faster than GCM, or sorry, CBC. So this is what the hell is that? Yeah.
What's happening there,
Yeah.
or not happening?
He says this is just plain unacceptable. Obviously, we must have hit some nasty performance tag somewhere because this is comical. And sure enough, that's what happened. So he looked into it and looked in the AES_intel.s, which is the assembly file, and we see that it actually runs this instruction called CLTS. And he says that's the problem. The instructions on his list of instructions that cause VM exits conditionally, which means when they're running in a VM, they have to stop running in hardware virtualization and let the software do something, which is always a slow operation. So CLTS, the CLTS operation causes a VM exit if the bits in position 3, which corresponds to CR0.ts, are set in both the CR0 guest host mask and the CR0 read shadow, which is a bunch of hypervisor speak, or down in the CPU speak. But basically, that instruction signals the CPU that we're about to do FPU or floating point unit register stuff, which you do for AES and I, which in VMware causes an exit into the hypervisor because it has to do a bunch of work to fiddle that state. And we've been doing it for every single AES block. Needless to say, performing the equivalent of a very expensive context switch every 16 bytes, each block of AES, is going to hurt encryption performance a bit. The reason why the kernel is issuing the CLTS is because, for performance reasons, the kernel doesn't save and restore the FPU state on kernel thread context switches. So whenever we use the FPU registers inside the kernel, we must disable kernel thread preemption via a call to the kpreempt disable, and then once we're done, kpreempt enable, to save and restore the FPU register state manually. During this time, we cannot be descheduled, because if we were, some other thread could go in there and clobber the FPU registers, and then when we get rescheduled, we'd be working with unknown state. So if the thread does this for too long, it can lead to a latency bubble, right? So if we let it just take arbitrarily large chunks of data and try to encrypt them all at once in such a way that we didn't let anything else run in the meantime, that would cause the whole machine to chug every time we did it. So that would be bad. But
very bad.
if we do the smallest possible chunk every time, the performance is going to suck. So he says the solution was to restructure the AES and or the AES code and the kernel crypto framework, block crypto implementations in such a way that we execute encryption in meaningfully small chunks. So he decided that we can do up to 32 kilobytes at a time, for reasons which he'll explain below. But basically, at the rate that any modern processor with AES and I can do, we should be able to do 32K in like 0.1 milliseconds. So that's short enough that it's not going to cause us hiccups. Unfortunately, doing this restructuring work was a bit more complicated than one would imagine, since the kernel crypto framework, or in the kernel crypto framework, the implementation of AES and the block cipher modes is separated into two separate modules that interact through an internal API, which wasn't really conducive to high performance. So anyway, with the fix to doing 32K chunks, he got some more acceptable results. AES CTR at 400-ish megabytes a second. Same for CBC, which is unexpected because we expect CTR to be much faster than CBC. And AES GCM was now 250-ish megabytes per second. So much better performance, but still not up to what we expect. He says
there's room for improvement.
Yeah, he says it's not disastrous anymore, but it's still very, very bad. Of course, we've got to keep in mind the thing we're comparing to, OpenSSL, is no slouch, right? It's got handwritten, highly optimized inline assembly that's actually written by Perl so that it can be adapted to different processors. So it's really complicated for most of these encryption functions and the specific modes for a lot of different platforms. But he says that's a ton of code to maintain and optimize, but I'll be damned if I'm going to let this kind of performance gap persist. He says,
scratch the itch.
Fixing this, however, is not so trivial anymore. It pertains to how the kernel crypto framework block cipher mode APIs interact with the cipher algorithms. It is beautifully designed and implemented in a fashion that creates minimal code duplication, and this also means that it's inherently inefficient. So for the ECB, which is the Electronic Code Book, CBC, Cipher Block Chaining, and CTR, which is counter mode, he added the ability to do an algorithm-specific fast path implementation of the block cipher mode. So the IllumOS kernel crypto framework supports data coming in either as one big buffer or as a scatter-gather type thing, or various different unaligned bits or whatever. But if you're using this in a performance-sensitive context, you probably have one linear buffer, in which case you can skip a lot of this code in the crypto framework. And so he basically detects when everything is optimal and skips the slow path if he can.
Okay.
So he says CTR and CBC decryption benefits enormously from being able to exploit the wide XMM register on Intel processors to perform the encryption and decryption operations on 8 blocks at the same time in a non-interlocking manner. So if you can actually feed it 8 blocks to decrypt at once instead of one at a time, you get 5 to 8 times the performance.
Of course, yeah, that's an improvement.
CBC encryption benefits from not having to copy the previously encrypted ciphertext blocks into memory and then back into the registers to store them with the subsequent plaintext blocks, right? Because the way CBC works is you're using a bit of the encrypted output from the previous block as the key for the next block. But if you do one block at a time, it means you have to be like, all right, now I need to go get a copy of this chunk from the old block in order to use it as a key each time. But if you can give it a bigger batch at once, it already has that data handy, and it doesn't have to do the extra copy. So with those changes, it was a bit more modest, but 1.3 to 1.5x improvement. So
yeah, it all adds up at the end.
At the end of all that, he now had much better performance. He was now getting 3,100 megabytes per second of counter mode, and about a little bit more than 1,000 megabytes per second of GCM mode. So he was actually getting twice the performance, or he's getting slightly better performance than what OpenSSL was, or within the margin of error, as you can see from the graph. But for CBC mode, he was actually doing much better. So you can see the graph here. So the blue was what he got when he started. The orange was after fixing it to do bigger chunks and not have to do the VM exits as often. And then the yellow is the fast path improvements, and you can see the green is OpenSSL. So in ECB mode, he actually eked out quite a bit of extra performance, although that's not a cipher anybody's going to use, but it's a good benchmark in this case. In counter mode, you can see OpenSSL is still a little faster, but that's okay. In CBC, he actually managed to eke out a reasonable performance gain, and then in GCM, we see it's about on par. So in the end, he managed to get the IllumOS crypto framework caught up with OpenSSL, basically.
Yeah, that's impressive.
So when he and I were discussing it the other day, and he linked me to this blog post, I started looking at what FreeBSD does. Now, these benchmarks aren't directly comparable to his because I'm using a very different processor.
Of course, but things you could take over.
I compared the FreeBSD's crypto framework, which is actually Open Crypto, which is shared between OpenBSD and FreeBSD, although FreeBSD has a couple new algorithms that I don't think OpenBSD has copied back yet. But compared 8 kilobyte and 128 kilobyte blocks in FreeBSD's kernel versus the 8 kilobyte blocks in OpenSSL. So for ASCBC, we get about the same performance. And we get slightly faster by using the bigger chunks, but in the end, about the same performance as OpenSSL. With AES-256, we see, again, about the same results. In counter mode, which in FreeBSD is called ICM for integer counter mode instead of CTR, we see that the block size makes a big difference. At 8K blocks, the Open Crypto framework can only do about 800-ish megabytes a second. But with 128K blocks, it can do about 1350. Of course, OpenSSL can do 1800 with 8K blocks. So we need to at least double the performance of the FreeBSD one to catch up to OpenSSL there. For XTS, which is the type of encryption used for disk encryption, so that's what's used in Geli by default, or maybe not by default, but what is used by the installer in Geli by default. With 8K blocks, we're getting only about 800 megabytes a second. Although for Geli, you really need to test 4K blocks, because that's usually what you're actually doing. So about 800 for XTS, which is about the same as CTR, because it's pretty much the same algorithm, but XTS does it slightly differently because it's meant to be read different sectors randomly in the middle of the hard drive at any time instead of having to read them in order. And then when you went up to 128K blocks again, you get to 1,300 megabytes a second, but OpenSSL can do 1,600 megabytes a second. So again,
okay.
we can probably about double the performance of the 128-bit version. Although the 256-bit version, FreeBSD at 8K got about just shy of 700, whereas OpenSSL got about 1150. So we can't quite double the 256-bit, so we're not quite 2x slower. So that's pretty good. And then ASGCM, which is the one we care about mostly for things like IPsec and SSH and so on.
Yeah, everything that basically hooks into the Open Crypto framework and takes their...
Well, in particular, GCM is one of the two options that'll be available in the native encryption in ZFS. It'll be GCM and another one called CCM, which is actually a combination of counter mode and CBC for a Mac. So GCM is the one I care about in this case because it's the one that OpenZFS will be using. With 8K, with 8K chunks in the kernel, we got about 500 megs a second. With 128K chunks, which is what OpenZFS will probably do for most of it, that was 668 megabytes a second. But OpenSSL can do 850.
Yeah, okay, there's still room for improvement, but it's a good start.
Yeah, so if we can make some of these improvements and get the XTS one a bit faster, that'll help Geli, and the GCM one faster will help a lot of different things, including IPsec and the storage encryption.
Okay. Are you the only person working on that? Or
I don't know of anybody else working on it, but I only started looking at this on the weekend after talking to Sasha in the OpenZFS channel.
Okay. Yeah, that sounds like a worthy effort.
Yeah.
I mean, everyone could benefit from that.
Well, it actually, the conversation started, Matt Aarons linked an Oracle article about their performance, although it turns out their article was mostly about how Spark is better than Intel, because it's, I think, an article they inherited from Sun. But it got us onto the topic of these benchmarks, and then Sasha linked his, and what he had done is created a kernel module called crypto_test for IllumOS that verified against the known answer tests that he hadn't broken any of the crypto when he was doing all these modifications to it. And then secondly, he added a benchmark to it. And I thought, so I basically ported his concept over to FreeBSD. So I stole his known answer tests, although I added a couple extra of my own because I was having some problems. It turned out I wasn't using it right. But all the code that actually implements the encryption stuff is completely different on FreeBSD, so it's not really a port. But I stole his idea shamelessly. And with a link to his work and his blog post about it in the comments at the top of the file. But I basically have a kernel module that can verify that the encrypto works properly on FreeBSD, and then can run a benchmark to tell you how fast it is. And I also plan to run it on a couple different machines. Like the one machine I've benchmarked so far is one at my house. But in the FreeBSD test lab, we have a good selection of machines. In particular, I'm interested in the E5 1650s that are like 3.5 gigahertz, whereas most of my servers only like 2.5 gigahertz. And I want to see how big of a difference there is in the OpenCrypto versus OpenSSL in the case of a faster CPU. And also probably using some dtrace to figure out where time is being wasted in the OpenCrypto bits.
Yes, yeah, that's the good approach. And I mean, if you have a version that people can try out, then we can maybe have a call for testing or something to get a lot more performance data for comparison. But yeah, I see this as one of the nice things that we can, share back and forth between the IllumOS project and us, and other people or other projects can benefit from that as well if they have similar improvements in their systems or are using the Open Crypto framework.
Yeah, one of the interesting things about the Open Crypto framework is it's specifically designed to support offload to hardware as well. They're a little less popular now, but they used to be really popular to have these PCI crypto offload cards where you'd have them, they had ASICs or FPGAs that were specifically designed to do certain types of crypto work. That's become a little bit less popular now, but then we're getting things like Intel's Quick Assist, which brings that idea back. So I think that's why it's important to make sure our Open Crypto framework is up to snuff on this. In particular, one of the other things is, while you can provide an arbitrarily large buffer to do the work on in the Open Crypto framework, if you then later want to add a second buffer, you have to do the whole, even if you use the same session, you're still rekeying each time. So I'm interested in wondering if there's some API enhancements we could do to allow us to say, all right, now here's another block I would like to encrypt with the same key. Now, in the case of Geli, you don't do that because each sector needs to be encrypted with a different initialization vector. And every couple of 100 megabytes is actually a different key as well. And then, like even in ZFS, each block is eventually going to be, each block will go into the Open Crypto contiguously as, 4K or 128K or 1 meg or whatever it is. And a second block will likely have a different IV. So maybe some of these, it's not necessarily a big deal, but it might be helpful to have something like that, even just for the benchmarking, to see how much time is wasted on the rekeying versus actually just doing the crypto. The other thing I want to do is actually look at the OpenSSL code, which I might regret, and see how it's doing the benchmark and make sure we're actually comparing apples to apples. If it's not rekeying each time, then we understand maybe why Open Crypto might be a little bit slower. And that's why maybe for the Open Crypto benchmark, we want to not rekey, even though it's just the benchmark and isn't actually what we're going to do. It's hard to say. But again, hopefully dtrace will be helpful in figuring out what's going on here.
Yeah, that needs some more work, but I think you have a good approach to, not only do the work, but also do comparisons in between to check your results and see that you're actually getting improvements and not making it worse.
Yes, and we'll make sure that, it still actually encrypts things correctly.
Yeah, still that you can get your data back once it's encrypted, and things like that. Yeah, it's not just performance optimizing, and you still need the whole thing to do the basic thing that it does, the encryption work itself.
Yep.
Okay.
Yep. So next is yours.
That will look out for new things. So now I have a new thing, which is actually kind of an old thing because I guess some people have already seen it, but we have not mentioned it in the show before. So we thought we might catch up to that one, which is many of you hopefully know about Brandon Gregg, which is the senior performance expert at Netflix. And of course, or at least some of you know his homepage at brandongregg.com. And he has a nice special section there talking about some of the system administration utilities he's written in Perl. And the whole page is a nice collection of interesting software that he has written to, I think, with a little bit of a smiley face attached to it.
Cheek for sure.
Mm-hmm. So there are utilities like the triple ROT13 encryption algorithm, which is an interesting twist on the original ROT13.
Yeah.
And all these kind of utilities, and or there's another utility called /userbin maybe, in contrast to userbin true or userbin false. So in case you are too limited in true and false cases, you might want to add another one to it. Then you can use the maybe one, which might execute that instruction, or maybe not.
I like the baud command. If you just do baud -9600 ls -al, it prints out the text as if it was being transmitted at 9600 baud. You can feel like I used to feel when I used SSH phone.
Back in the day, it's been a while, and some people might be nostalgic about this and want this experience back, so that's a good way of getting it. Or you might check out your the bottom command, which shows you instead of the opposite of top, it displays the processes that are using the least CPU on your system. So if you want to know what's the least expensive process to run on your little machine, then check out the bottom command, which is a similar layout as the top command, but it's just displaying the reverse.
Yes, although I love these next two that I have. OnStat, which tells you whether or not your server is on.
Yeah,
you just
in case
run
you don't...
OnStat and it tells you the server's on or if it's not. And then OSStat, like we all familiar with like IFStat and NetStat and SciStat and so on, and IOStat, but OSStat tells you the version of the operating system you're running every 1 second.
Yeah, in case it changes suddenly and you want to know about that. So run this command periodically and get notified if something changes in your actual operating system.
Yes, or the chat room loves this one. CD rewind. Rewind your CDs before you eject them.
Yeah, of course, because you always want to have the rewinded version when you put it back in. You have to be a little bit more careful about that. So always rewind your CDs when you use them. Yeah, and it goes on and on. There's a couple of nice utilities there. So we won't cover all of them here. Check out that webpage. It's brandongregg.com/specials.html and find a little funny nugget here and there to impress your coworkers. Or in case you have a similar utility that you wrote and think that's useful for our readers, then you can send us an email about that at feedback@bsdnow.tv and we'll cover it in a future episode.
Yeah. Also have Leet, which transforms a text file into Leet speak with varying degrees of replacement. How much do you want to return?
Yeah, so things like that keep the daily life of a sysadmin interesting enough and has some funny moments in there. Or show it to your coworkers and let them wonder about what this crazy bottom command will display.
Yeah, or LTZip, which is a lossy text compression algorithm. So if you compress the license agreement for Spark, you get back a lot less text. See, it's smaller. It's called compression, but it's lossy, so you don't get it back. And then the last story we have is, remember to turn your computer off before midnight, January 18th, 2038.
Oh, yes. Yeah, that's an important date. So huddle under your blanket on that date or face the truth about what kind of crazy things are going to happen in computer systems around the world. Yeah,
so the author says, I remember the Y2K problems quite vividly. The world was going crazy for years, paying insane amounts of money to experts to fix critical legacy systems, and there was a never-ending stream of predictions from the media on how it was all going to fail. Most don't even understand what the problem was, so I remember one magazine that had the following, and this little excerpt from a magazine doesn't say which one, but this one's scary how little people understand about computers. Right? So, most systems store the current year as a 2-digit value to save space. When the value rolls over on New Year's Eve 1999, those 2 digits will be 00. And 00 means the halt operation in machine language in many central processing units. If you're in an elevator at the time, it will stop working and you may fall to your death. It's like, really, suddenly going to start trying to execute text strings, is it?
Apocalypse Now, yeah.
This is, I still don't know why they thought a computer would suddenly interpret data as code, but people believe them. You could see a nearby hydropower plant from my parents' house, and we expected it to go up in flames as soon as the clock passed midnight. Well, at least 2 airplanes crashed in our garden at the same time. But then nothing happened. I think one of the most severe problems was that the police were not able to open their car garages the next day because their RFID tokens had both a start and an end date for validity, and the system clock had actually rolled over to 1900, so the tokens weren't valid yet. But
just have to wait a couple of years. Yeah.
But that was 17 years ago now. One of the reasons why Y2K wasn't as bad as it could have been is that most systems don't actually use a 2-digit year representation internally. That was just for the text. But instead use some form of timestamp relative to a fixed date or an epoch. So you can see some examples here. DCF77 and WWVB actually transmit the year as a 2-digit number. So the devices had to use information from other contexts, like the product was not on the market before this year, to make an educated guess about what the current century is. The function 2a in which is get date offered by the int21 BIOS instruction for DOS returns a year field between 1980 and 2099. So that would still work up until 2099. Unix and Unix-like systems traditionally use the number of seconds that have passed since January 1st, 1970, stored as a signed 32-bit value for all their APIs. The rollover will not happen before January 19th, 2038, when the counter jumps back to December 13th of 1901. If the system can handle negative values correctly, that is. On Windows, the Windows 32 API returns a value between 1601 and 30,827. So Windows might actually be okay. The standard C functions for timekeeping on Windows, however, use a 32-bit Unix timestamp and therefore will overflow in 2038. So while Windows might kind of work, most of your applications might not. The FAT file system uses a value that can express values between January 1st, 1980 and December 31st, 2107. So FAT will keep working until 2107.
Because we all use FAT.
Well, and hopefully by 2107 we'll be rid of FAT. But judging by the fact that we're putting this in as the EFI system partition, meaning it's going to be around a lot longer than we hoped. NTFS uses something similar to the Windows API, except for I'm guessing isn't signed or something. So it actually supports values between January 1st, 1600 and May 28th, the year 60,056. It's future-proof.
Yeah.
Interestingly, Linux file systems like ext2, 3, and 4, XFS, and ButterFS use the Unix 32-bit timestamp or have already switched to a 64-bit timestamp. So hopefully most of them won't be affected. The Network Time Protocol uses a 32-bit value for the number of seconds that have passed since January 1st, 1900, which overflows in 2036. So they use an unsigned value, so it doesn't support negative, and they started the epoch they chose was January 1st, 1900. So it will actually run out slightly sooner in 2036. Although there's some interesting bits about that. The CD-ROM format, on the other hand, ISO 9660, stores the year as a 4-digit ASCII number. So it'll actually be fine until 9999.
Okay.
The Digital Video Broadcasting System, DVB, uses a 16-bit counter to transmit the dates of the electronic program guides in a modified Julian calendar and will overflow April 22nd, 2038. So everybody else will freshly be finished panicking and crashing and so on, and then their TVs will stop working. Early Apple Macintosh computers that have the HFS or HFS Plus file system count the number of seconds since January 1st, 1904 as a 32-bit number, and those ones will wrap February 6th of 2040. I'm guessing they chose 1904 specifically to make it go until 2040 instead of 2038. I don't know. That one's special. The IBM System 370 mainframe and its successors count the number of 2 to the negative 12 seconds, or 0.244 nanoseconds, units since January 1st, 1900, using a 64-bit counter. So that will actually end up rolling over in September of 2040. So they used a really big 64-bit value, but they count every 0.244 nanoseconds. So the counter goes up really fast.
Which is...
Yeah. And then the global positioning system counts the number of weeks since January 6, 1980, using a 10-bit counter, allowing for 1024 weeks. The rollover has actually already happened at midnight, August 21st of 1999, and will next happen the night of March 31st into April 1st in 2019. And it's always being within the responsibility of the user to consult their sources and choose the correct 1024 week block. So really old GPSs might stop working in 2019.
Which is probably a good reason to buy a newer one.
Yeah.
Just in case.
So then it looks at what might actually happen. The actual problems with date and time rollover is that the system calculates the timestamp differences a lot, right? Like oftentimes you just check how long it's been running by looking at when it ended, subtract when it started. But if the value of when it ended is now, because of the overflow, is now a smaller value than when it started, you will get that it ran for a negative number of seconds. And that'll cause all kinds of problems.
You have to account for the math that's happening there.
Yep.
Yeah, in that specific case.
And an example of this is there's a bug in the generator control units, or GCU, on Boeing's new 787 airplanes, the Dreamliner, that was discovered in 2015. An internal timestamp counter overflows every 248 days because they count, they go up once every 1,000th of a second. So once every millisecond. And so that's the 2038 thing, but 1,000 times faster. So every 248 days, it'll overflow, which will trigger a shutdown into a safe mode. The aircraft has 4 generator units, but if they all powered on at the same time, they will all fail at the same time. This sounds like the overflow is caused by using a signed 32-bit counter that counts the number of, centiseconds, which is 100th of a second, which would overflow every 248.55 days. Luckily, the the FAA now mandates that those Boeings be rebooted every 21 days.
Reboot that aircraft.
Like I think something else ends up using milliseconds and has this problem every 24.8 days.
That's a little bit more critical.
So they reboot them once every 3 weeks, and then that doesn't happen.
As part of the regular maintenance interval.
And so they talk about a bunch of this. They say, so the obvious solution is to simply switch to 64-bit values for all these things. Although, how did that apply to a bunch of 32-bit systems that, where it's a lot more work to calculate a 64-bit value? But even that doesn't necessarily solve the problem for you. Because, just because your operating system keeps working doesn't mean your app will. In particular, when you write stuff down. For example, databases store dates as numbers. And that means if you wrote a database today and it used a 32-bit number, if it overflows, then it'll be problematic. But also, it just means the entire database would need to be rebuilt because there's only this much room and there's data on either side. You can't just grow that field in the middle of the database. You'd have to basically resynchronize the whole database with a wider field for all the dates and so on.
Especially that's difficult for problematic for long-running databases that store a lot of data over time.
So the other problem is that some of these things we can run into already. In particular, now that 2038 is only 19 years away, it turns out some systems at banks that calculate mortgages. If you took out a 30-year mortgage in the year 2008, you could have triggered this bug at your bank already.
Yeah. That would be an interesting conversation with the bank.
And so this actually reminds me of the talk that Theo Dirac gave at BSDCon 2013. And his main point was the life cycle, a lot of these embedded things like SCADA controllers that control pipes at, say, oil refineries and oil wells. They have a lifetime of about 14 years. And then, they spend a couple of years designing it first. Meaning if we want to have embedded systems that will handle this correctly, and we want them to be in place before 2038, we need to design them like last year.
Yeah, and should have already put them out into the field.
Yeah, or they should at least be going into production.
Every single device.
Yeah, every single device has to be replaced by then. And a lot of these devices, we've all heard stories of 20-year-old devices out there. And we don't have that much time left. So we really need to start replacing stuff so this doesn't happen. So there's more about
because
how it affects NTP.
We might encounter some system everyone has forgotten about that has this problem then, and we were all wondering, why did we think about this one system way back there in the corner?
Yep.
It was always working, and then it flowed over in the timestamp, and then
you get thinking about, how many times have we found out that such and such a device runs some kind of BSD and we didn't know it? And it's like, oh, well, it's running BSD 2 dot something from before 64-bit was even an idea in anybody's head.
Yeah.
So the article's got a good list of a lot of the different C and system calls that return times that you might not think of that are going to be problems, and lots of things to consider.
Yeah, I think also universities should put this into their curriculum, like letting students not only write programs that take care of that, but also try out what happens in their programs when they set these timestamps to overflow, and see what reactions they get from their, GUI applications or embedded applications that they are writing, because that's an actual problem that we're still having to deal with.
Yeah, JDE in the chat room says, believe it or not, a lot of your SMS messages probably go through an OpenVax running SendMail.
Yeah, because it's been running so well over the years, and why should we change that at all?
Yeah. So there's lots more in that article if you want to read more about it. But I also have links here to Theo's presentation from EuroBSDcon in Malta, where he talks about
2013.
Dealing with this problem, and how he plans to be on a tropical island somewhere, because he's not convinced that we'll still be able to make and ship food to grocery stores when this happens, and so he's going to be somewhere where he can survive off the land, basically.
Just a couple of weeks until the most damage has been cleared out. Yeah. Will be interesting. Panic wouldn't help anyone, I guess, but I think preparing is a good thing to do. So in this section, we are going to cover a couple of smaller things here. So first of them is today's Michael W. Lucas of BSD book fame about Get Your Name in Absolute FreeBSD 3rd edition.
Yeah. So first of all, he's writing news that he's finally going to do Absolute FreeBSD 3rd edition, which is a big textbook style book about everything you need to know to get going with FreeBSD. The last one is, the second edition is over 10 years old now, so it'll be really good to have a fresh one.
Yeah, because a lot of things have changed in the system, and it's time
of course, the biggest problem I'm having as reviewing his stuff is trying not to be like, well, we're going to change that in the next couple of months.
Yeah, that's always the problem if you're writing a textbook for a system that's undergoing changes all the time. But I think there's still more new things than relying on the old second edition.
Yep.
So what he does is he's running a charity auction and benefiting the FreeBSD Foundation. So thanks for that. So if you want to get your name into the 3rd edition, then you basically have to
because of the way
start betting.
Because of the way Michael Lucas writes his books. It's basically a story where you're following a user through having to do all these things, right? And so the auction is for your name to be the person who's being picked on throughout the book. So people will bid. I think the highest bid is up to $500 now. And you can have your name be the name of the character that's, using FreeBSD and going through this whole book step by step.
Yeah. So there are a couple of rules about the auction itself and what kind of names you might be allowed to use in there, and some things that he defines as certain rules that should still be followed, although
But
this is going to be
the important one is the deadline, which is Monday, March 27th. So that doesn't leave very long. So if you would like your name to be the name of the person in the book, then you should go to his blog that we've linked in the show notes and bid soon.
Yeah, so check that out and bid if you are interested in getting your name into book fame for the 3rd edition of FreeBSD.
So the next story, I guess this is mine, kind of. That last week I added a new feature to the top command on FreeBSD. So FreeBSD recently inherited from OpenZFS support for compressed arc. So that is, the arc is the file system cache in ZFS. Now with this new compressed arc feature, it means that when a file is compressed on disk, because you have compress equals on or compress equals LZ4, it takes up less space on disk. But before, it would be decompressed and then stored in the cache and sent to the user when they tried to use it. Now, the cache will actually store the compressed version rather than the uncompressed version. And there's actually a small subcache of decompressed versions of the most popular compressed things. But the idea there is just to avoid decompressing the same file multiple times a second if you're using it that much. But because LZ4 is so fast, you're doing, gigabytes per second per core, it doesn't really hurt to have to decompress the cache many times. So anyway, it means that the same amount of RAM will now cache more files if your files are compressed on the disk. So on my build machine, where I have many copies of ZFS checked out and so on, I currently have 54 gigs of data in my ARC, but my ARC is only using 32 gigs of RAM, meaning I'm getting 1.76 to 1 compression ratio. So I'm actually getting, 75% free extra cache without using up the RAM.
Yeah, which is good because we can cram a lot more data into that. And that was basically developed or has been discussed at the FreeBSD Storage Summit in February.
Yeah, so...
so basically, you had that feature mostly ready there?
No,
did you wrote it there?
I wrote a summary of what new features had gone into FreeBSD recently and realized that compressed arc was there now and that the stats for it existed, but it was hard to
find out what the actual
and then I had to figure out what they actually meant and what they were talking to. And so anyway, I added as an extra line to top, and then you pointed out I didn't update the man page, so I'll have to find the man page and update that as well.
Yeah, okay. But that's fine. I mean,
just to explain
MFC is happening in 2 weeks.
I just got to explain the field so that makes sense.
Okay. So that's something we can look out for into the newer versions of FreeBSD that are coming out, or if you're running ahead, you can.
But yes, it should be MFC in time for 11.1, which I guess we'll have to talk about next week. The schedule for that was announced.
Yeah.
So next up, we have some Dragonfly news.
Yep. So apparently there's a simple fix for speed, and apparently Matthew Dillon always attributed speed issues to writing transaction history. Matt Dillon actually discovered that Hammer was repeating itself when writing to disk. And so basically it wrote things twice.
Yeah, so it would write out 32K of data and then write it out again over top of it. And so when he fixed that, Hammer now writes data twice as fast.
Okay, yeah, simple fixes like that, make a huge impact. So this is something you can find in the 4.6 version of the upcoming Dragonfly BSD release. And yeah, check that out if you're running Hammer or want to try out Hammer. That's something they are doing.
Yep. So then Ted Unangst has an interesting recent blog post called Meaningful Short Names. So he says, why don't Unix commands have any vowels in their names? Why do we have CP and MV, which are obviously devoweled stand-ins for copy and move, but are less intuitive to new users? A user wants to copy a file. Why shouldn't the name of the command just be copy? But what exactly does a user want to do? Instead of copying files, maybe they want to link to files. What does that mean? In Unix, we have hard links and symbolic links. If I replace the original file, do I want the link to refer to the original file, or to the replacement. Or maybe what I mean by link is combine two object files into an executable. So what do we call that instead? Ln is the command, is the name of a command, but link is the name of the concept. And that concept can be ambiguous, and you could be linking files or linking objects to make an executable. grep is a remarkably useful tool, but it's the most unintuitive name. Why not call it find like they do on Windows? You want to find some text. But then we have a find command on Unix, and that's to find files in the file system. That kind of makes sense too, not finding strings in a file. So what command should you call? What should you call the command to find files in the file system? I was like, well, that could be locate maybe, but locate uses a database, doesn't actually search. So is it the same thing? And so on.
It's difficult to find the right names for these kind of concepts.
There may be a great deal of historical accident in the names of these commands. What if the inventors of awk had had different initials? But that does
or rearrange them in a different order.
But that doesn't mean we can't recognize the value of unique and precise identifiers. It's you can see how much trouble we can end up having just trying to name find.
Yeah, it's just a simple utility, or not so simple, but still the functionality to express the need or the command that you're inputting that you want to run.
Yeah, and lastly, we have a reminder here: more opportunities to spread the word about your work in with FreeBSD. So we have two conferences
are coming up, and their call for papers are still open, or just recently.
Yep, they're open until the end of April, basically. VBSDcon, which will be September 8th and 9th in Reston, Virginia. I'm on the program committee for that, so I'm really, really trying to get as many submissions as possible so we have the best stuff to pick from. So you have until April 29th to submit that, and we're using the EasyChair website to do that, so you should be able to submit it there, and it should be easy. Presentations should be 45 minutes long, and then we'll add time for question and answer at the end of that. And you can find out more on the specific page for that. But we're really hoping for lots of sysadmin targeted stuff as well as developer targeted stuff. That conference always has a really good sysadmin turnout because it's kind of in the Washington, D.C. area, and there's a lot of that type of stuff going on in there. It's always been a really good conference, and I'm looking forward to it this year.
So that's running twice.
This will be the third time.
Every other year?
It runs every second year. This will be the third one. And it basically runs in the years where there isn't a Meet BSD.
Okay. So they switch around.
They switch back and forth between East Coast and West Coast. But it's a really good conference run by the people at VeriSign as their way of giving back to the community since they use BSD to run, .com and .net root zones.
Yeah, great. We're thankful for that. And the other conference is, of course, EuroBSDcon 2017 in Paris, France, from September 21st to 2014. EuroBSDcon is the European technical conference for users and developers of BSD-based systems. And submission deadline for that one is April 30, 2017, so end of next month. Yeah, next month. Right. We're still in the March. I'm already ahead of myself. So they are looking basically for BSD talks about not only specific topics of not only sysadmin stuff, but also implementation, architecture, applications, performance, security. So everything that's centered around BSD-based operating systems in various topics. And you can also submit full or half-day tutorials to that one if you're more of a tutorial guy. And the tutorials or the talk submissions can be done via their EuroBSDcon website. They have a link to that. And there is all the information about the venue already up and what kind of places it's going to be at, and something about the social event already. So that's going to be very, very interesting,
yes,
I guess.
I'm also expecting there to be a pretty good partner program for that conference because I know that I'm not going to be able to go without taking my partner with me.
Paris, I mean, France.
But
Yes.
they also say
That's a good reason.
the IllumOS program committee is also inviting qualified practitioners in their field to submit proposals for half-day or full-day tutorials on topics relevant to development or implementation using BSD operating systems. So things like Benedict's talk about how to use Ansible. If you use anything of that nature or do anything interesting with BSD and want to teach it, we really would like to have a good selection of those to attract more sysadmin type people to our conferences.
Yeah. Submit something, and we'll see you in Paris.
So the feedback section of the show today is brought to you by Tarsnap, online backups for the truly paranoid. So,
Tarsnap, yeah. Online backups for the truly paranoid means that Tarsnap is a secure, efficient, and online backup service. So it encrypts all your data that can be accessed only by you with your own personal key, and no one else can access those data except, only you, because you're the only person having the keys for it.
The important thing is, lots of backup places claim they do encryption. Tarsnap does the encryption on your machine with source code you can read, and then only sends the encrypted blocks to the cloud. So the unencrypted data is never sent over the wire. And you can verify this by looking at the source code and building the binary yourself if you're paranoid. Whereas most other services of this type, you would send them the data maybe over an encrypted tunnel, but the data would be unencrypted, and then they'll encrypt it for you with one key for everything. It's like, well, that doesn't really help anybody at all. So yes, Tarsnap is the only way in order to ensure that the stuff you back up in the cloud can actually be deleted. It's basically impossible to delete stuff in the cloud, or to be 100% sure that you got every copy of it, because there's so many backups and replicas and broken hard drives and so on. And so if you have the only copy of the encryption key, you can destroy that, and that's the only way you can be sure that the data is not usable in the cloud. And so it's the only way you can ensure that you can actually delete the data from the cloud when you don't want it to be there anymore. And with prices of 25 cents per gigabyte, it's, easy and cheap to back up all your important documents and files and source code. Plus, with its unique differential encryption or differential compression, it means that all the files get deduped and then compressed before they get sent to the cloud. So you only pay for what's actually new each backup, not all your data every time.
Yeah, that saves a lot of bandwidth already, and you will not submit multiple times your data that has already been stored on the remote Tarsnap system.
Yep. Okay, so our first feedback question is from Craig. He says, Dear Alan and Benedict, I'm a Linux admin who isn't afraid to dip my toe into the BSD waters occasionally and love listening to the show each week, even though I'm not really a BSD user. My question for the feedback is this. In one of the recent episodes, Alan stated that it takes many more admins to manage 1,000 Linux servers than it does to manage 1,000 FreeBSD servers. What tools, configurations, and practices are there in FreeBSD that make this statement a reality? Well, that was more of a general observation, is the size of the teams I've seen managing those, not necessarily that it's impossible to manage 1,000 Linux servers without a lot more people. But I think a lot of it is more control over everything. The fact that in BSD you have the concept where your configs can be derived, or where you can have global config and local config. Like you can have rc.conf and rc.conf.local, and rc.conf can be the same on every machine, but rc.conf.local has specific bits that are local to each machine. But I think the biggest one is control over packaging. The fact that you get the tool Poudriere and you can build your own complete set of packages, whether those are stock, the head version of the ports tree, or the quarterly branch, or your own branch.
Specific options.
Or, you have your own category of local additional ports, and it just makes it so much easier to make sure that everything works. And the other big thing is that you get that control over the packaging across all versions of FreeBSD. Meaning your FreeBSD 10.3 and your FreeBSD 11 and your FreeBSD 12 machines can all have the latest version of Nginx and be the same or be different. It's up to you. rather than depending on necessarily upstream packages. Although even the upstream packages in FreeBSD, you get the latest stuff on all versions of the operating system, not only the newest version. Oftentimes if you use an older version of a Linux distro, then you get older packages. And it's like, well, my web app needs newer versions of this package, and then you have to go and do all kinds of terrible things to try to meet the dependencies. Whereas in FreeBSD, you can get new packages for every supported version at any time. And a lot of it just
small
has
things like that.
But the other thing I think is the separation of what is the base system and what are the packages and third-party bits. Makes it easier to decide which parts you're going to change and which parts you want to keep the same.
And actually find the configuration file. So if everything is stored in etc, for example, then it's a whole mess of config files that might be duplicated. And if you have a separation between /etc and use a local etc or use a local share etc, there is a lot more order in that itself, so you can find all the third-party software configuration files in that.
Separating the stuff that's included in the operating system and the stuff that you installed means that you know where to look. And it means you can also replace, say, the version of OpenSSL that comes with the base system with a different version, and it's not going to try to read the old config file. It knows, hey, my config file is over here. So you can even have two different versions coexist peacefully because they look in the right place. So next question is from Michael. You want to read that one?
Yep. So it says, hello, Alan and Benedict, and now Benedict. Got a bit of a quandary here, which I'll admit is mostly due to my lack of networking knowledge. I'm looking at moving into the NetOps team where I work currently, so I'm on a bit of a crash course to get up to speed. I love the concept of jails and even set up a couple of them on both FreeBSD and Dragonfly BSD, but in both situations, I'm having trouble connecting the jail to the network. I know that jails share the NIC and use an IP address alias, but does the alias have to be a valid address on the same network as the host? Would it be possible to set up the host in a way that allowed it to effectively behave as a router between some network jails on their own network and the office LAN? I know this is probably more difficult than I'd be able to pull off at this point, but I think the combination of ZFS or Hammer, jails, and the Linuxulator can really improve how things work at my company. I just need some direction or documentation to point me to the right direction so I can actually show the higher-ups how much better things can be.
Yep. So jails don't share the NIC. They only have access to an individual IP address, which is the alias you add. So normally, if you want them to be on the same network as the host, you just have a second IP address in the same network and put that one to the jail. If you want to use it as a router, what people often do is add another alias to the loopback interface or a new loopback interface, and then do NAT on the host to translate that subnet into a different one. Your other option, obviously, is you can create another VLAN, set it up on the host, and have just the one address for the jail in that VLAN, and pass that into the jail. The more complicated option is use vimage, and that gives the each jail its own Ethernet device, its own dedicated virtual NIC, and then you can bridge that or something. But probably your best bet is just VLANs, and then that VLAN interface has only the one IP that goes into the jail, and now that jail can talk on that VLAN, and it should be good. Other recommendation is Michael Lucas has a book called Networking for Sysadmins. And it takes the knowledge sysadmins already have and helps them quickly and easily learn the networking side of it. And I think that might be quite helpful to you in your situation of trying to deal with, I'm a sysadmin, but I want to move to the NetOps team.
Right. And sometimes it's difficult to find the right jail tutorials on the web that actually does this kind of networking.
Yeah. So in order to answer this question more specifically, I'd almost need to understand your network. So, how many different networks are there or whatever. But in general, you just set it up on the host and then pass the individual IP address. Maybe it's the only IP address in that subnet or whatever in that VLAN, but pass that one into jail and it'll just work.
Okay.
Next question is from Todd. He says, been a fan for quite a while, but noticed there was never an update to episode 7, which is building jails on FreeBSD. I was thinking it would be good to combine something like this article on freebsd.org in regards to passing the PCI device directly into a VM. But that's for Beehive, so I don't know. So he says, my system is 2 Xeons with a total of 16 cores, 64 gigs of RAM, and a fast ZFS RAID stripe array with mirroring and a dual 10 gig NIC. What I want to do is create the ultimate networking UTM/security and reporting device. So a PF firewall with CARP and RelayD combined with HTTPD for reporting, a UI on Blackbox and some other services I want to incorporate would be like OpenVPN, Libre SSHD. I think he means Libre SSL and SSHD. Reverse proxy and some sort of LDAP or PAM authentication. And network tools like Bro and IP2ban. It seems like a terrible idea to just go plonk everything into a single host and jail that versus using a combination of jails and Beehive to essentially create proxies between all of the services. It's kind of hard to explain, but he has a few questions. So let's see what we got here. Would it be best to separate all these features and security items? What's the best way to do it? So the ones that need fancy networking stuff, probably your Beehive is your best bet there because jails are really not designed to have raw packet access to the network. He says, if VM jails is the best answer, what's the most efficient way to communicate between them? You can just create a bridge and combine the taps for all the VMs and alias IPs for all the jails on it, and then connect it to your real network, and that should work. It says, if possible, I want to install Xorg/Blackbox and create a control panel UI for all the services. What would be the best way to go about that? We have an older tutorial where we show how to run, I think it was Firefox, in a jail with VNC. That might be a nice way to do your control panel UI thing in a jail.
Starting point, yeah. But he doesn't want to do some UI programming for Xorg or Blackbox.
Yeah.
It's just that they have a control panel where it could also be just a web page that lists
interesting
all these.
one is one of the developers from IllumOS recently just released on GitHub a desktop window manager specifically designed for kiosks, which that combined with like a web browser might allow you to just, have a dedicated kiosk mode that just runs a web browser, nothing else, and gives you that control panel that is maybe, say, HTML, JS, or whatever. That's the way most people have gone. So hopefully that helps answer your question a bit. It does seem obvious that somebody needs to write up an advanced tutorial on, advanced networking with jails.
There's a need for that, I guess.
And without vimage, especially since, vimage is not quite perfect yet, although it's gotten a lot better recently.
Yeah, we need to follow up on that. What's the latest showstopper on that one, or what's holding up people from using it?
Yep. And lastly, we have a submission from user Dave. He says, I'm sure our listeners will be interested in this particular PDF. Redundancy does not imply fault tolerance. An analysis of distributed storage reactions to single errors and corruptions. So this is actually a paper from FAST, the File Systems and Storage Technology Conference that happened in February, where we had the FreeBSD Storage Summit. And it said,
conjunction,
and it said, while testing ZFS in a non-mirrored config seems pointless, the commentary is interesting. The vast majority of databases tested both fail to detect corruption and happily propagate that corruption to the replicas, which might have had perfectly good versions of the data. In some cases, notably if the node is the current leader, then the entire cluster can become unavailable if those errors are diligently transferred to other nodes. So there's a whole paper here. But the one interesting excerpt they had, so basically, part of the takeaway is you really need a file system like ZFS that's going to stop corruption from being returned, right? File systems that don't have checksums, they read the data off the disk. If it's wrong, they just send it to the application anyway because they don't know it's wrong.
That's an issue that's also very near and dear to my heart because we have the same issue at the big data cluster at my university that I manage. So we're running all kinds of different NoSQL databases, and they also have a way. They're all running in the distributed mode across a couple of machines, and you have to have a way. So they take care of the whole synchronization between the nodes, but on the nodes itself, you have no way of knowing whether the data you're storing in this distributed manner is actually the data you were originally storing. So there might be bit flips happening or some other kind of data changes. And if it's not being stored at the endpoint on like a data set or a ZFS volume or whatever you have, then you have no way of knowing whether the data changed on the actual media before you distribute it to all kinds of partners that you have in your storage cluster. And that way you are just distributing the wrong data to your peers. And that's
so what's interesting here is if you end up with a file system like XFS or ext4, then if data gets corrupted, it'll get propagated and could take out your whole database. However, if you have something like ZFS, it will detect the corruption and return a read error instead. The problem is...
correct it if you have the proper
setup. If you have enough redundancy, it'll correct it. But they were specifically testing what happens if ZFS can't correct it. It turns out a lot of these database programs will panic and crash or exit when they get a read error, being like, I tried to read this data and it's not available. I don't know what to do. Shut down. Right? I imagine most times that's because they're worried. They're like, all right, you should fix that and then restart the database. But it turns out some of them have internal checksumming and recovery. So some of them, the fact that ZFS returns an error instead of the garbled data means if the file system returned garbled data, then the database would would detect the problem and maybe be able to correct it from one of the other replicas and continue. But because ZFS gives it a read error, it actually dies. But it turns out a lot of these databases don't really consider the option of the file system giving you an error. Now, even other file systems like XFS can give you an error if the disk is the problem. So it turns out a lot of these databases don't actually resist errors very well or handle them very well at all. Even just a single error can take out your database cluster.
Which is bad if you rely on that.
And so ZFS can protect you from replicating corrupted data, but it can't protect you from a database that if it does get an error, it just shuts down. It doesn't know what to do. It says, applications crash more often due to errors than due to corruption. In the case of corruption, a few applications like Log Cabin and Zookeeper can use checksums and redundancy to recover, leading to correct behavior. However, when the corruption is transformed into an error, these applications crash, resulting in reduced availability.
Yep. And it's also, if you're using distributed file systems like, I don't want to name any specific products here, but if you're using those, then you always want to make sure that on each individual node where you are storing the data at the end, there's some kind of way of detecting errors, and in the best case to not only detect them, but only to handle these errors when they are thrown in your application.
But the other interesting one is how a lot of these databases don't even properly deal with disk full errors.
Oh yeah,
it's like I know
that's
like
easy to simulate.
MySQL will sit there and start gobbling up RAM, hoping that some space will become available. But you don't want to just throw that data away and try to keep operating either. So it seems like a lot of these need to check the errors and make sure they do the right thing.
Yeah. So thank you, Dave, for that link. We'll check out that PDF more in detail.
Yep. Okay, so that finally is the end of this week's episode. That was quite an episode. It's been a long one. Yes. But we'll get our form back and get through this stuff a little quicker in the future. We just had a lot, partly because it's been a while since a last regular
conference
episode.
And
Yep. But if you have feedback or questions, which we need more of, please email those to feedback@bsdnow.tv. And we look forward to seeing you next week.
Yep. Enjoy the week in your BSD room or in your BSD world, and see you next week.
Yes. Also, if you watch this show live, next week will be a double episode because Benedict is going away the week after that.
Yeah, I have a teaching week coming up at a partner university of mine, and I will be in in the first week of April, I won't be in Germany, so I cannot access my equipment. But we will record an extra episode just for you.
Right.
So you won't miss me.
Yep. So, yes, if you watch live, show up ready for a double next week. Okay. See you next week.